You have now accessed Eclectic Gentlemen.
Here we are. How was your day today?
It was very back and forth. It was, I have to say, it was probably pretty good. Like, I wasn't supposed to be working today. I was supposed to be living through my house being pounded on while they replaced, a bunch of wood and...
On the roof.
Yeah, they're going to put a completely new roof on it, right?
My whole plan of recording a short 3 minutes to introduce today's guest did not really work out.
Shall we try it?
Well, we've been talking for 31 minutes, so this is the point where I will ask you, who's our guest today?
Our guest today is a good friend of mine from when I used to work at Goddard Space Flight Center. It's a NASA facility in Greenbelt, and it's funny because John and I actually we hail from the same local area in the Chicagoland area. We're close to the same age, so we have the same background in that area. So we ended up working at Goddard Space Flight Center in the Mission Design Lab for a year in 2009.
Yeah.
And that is a cradle-to-grave of basically space robots, which is really what a satellite is. And this is where I met John at Goddard Space Flight Center. So he's going to come over and he's going to give his rendition of all of this, and I'm probably going to distract him with a whole bunch of things that I'm really interested in.
All right.
That we talk about a lot. We get into really deep conversations, and so it should be interesting.
All right. Well, there you go. That's our guest for today. And let's roll it.
All right. It's 5 o'clock. Or close enough. How do you want to get started?
I'm rolling. It just got started.
All right.
There we go. We're
so
going.
John and I have known each other, God. Well,
15?
Go back further. We're from the same area. We both grew up just outside of Chicago.
Chicago suburbs, yes.
I grew up in Lake Zurich, which is probably about 15 minutes from where you grew up. And
maybe a little longer, maybe half hour.
Was it half day or Prairie Grove?
With traffic everywhere now, it's. I grew up in Vernon Hills.
I actually had a house there for a while.
I was born in Chicago, and then when I was probably like 5, we moved to Deerfield and Vernon Hills, Libertyville, all those northern suburbs. I think we were closer to Wisconsin than
Chicago.
Yeah,
that's true.
And you were like way far west, so we had the same snow and crazy weather and stuff.
My father used to tell this story all the time that there was one time when he was in high school where they took their father's car, and there was one stop sign between Lake Zurich, and downtown Chicago.
Wow, that's nuts. When I was really small, we were visiting my dad's friend, and he was on some farm out in Vernon Hills, and it was all farm country there. And in my lifetime, it's now like this, fully mapped out urban shopping mall, stoplight every quarter mile.
Oh yeah.
It's crazy. But anyway, things change.
I think there was in the low 30,000s of people in my town when I was in high school. And I think there was like 3 times that when I went back to visit.
Yeah, I still go back there all the time. My mom still lives in the area. I go visit her. My dad's in Chicago still. And
she's in Wakanda, right?
She's in Mundelein.
Yeah, we actually have a Wakanda.
Really?
Wakanda, yeah. Wauconda. Wakanda.
Okay. So it's spelled a little different. Yeah. Just a little different.
Yeah. But it is still pretty funny. Wakanda.
Yeah. No, it's a nice area. I like it. I don't like the Chicago traffic so much, but it seems like a reasonable place still.
Chicago is known to have some of the most aggressive traffic in America.
Yeah,
It's worse than
for sure.
DC, 495, all that.
Yeah, I think it actually is.
Ugh.
Yeah. Chicago would always make me nuts whenever I had to drive down there.
Although every place I've lived has you get like maybe once an hour, you get some crazy drugged out person going 115 miles an hour, weaving through traffic. You've seen that here on the Beltway, right?
Mm-hmm. I've seen
Just
that.
nut jobs. I don't know what they're doing. I think it's a video game or something, but that's in Chicago too. But I've seen it here.
The last time I saw it was when I was in Memphis. I saw it there more than I have anywhere else. Like every time I went out to go someplace and get on the highway, somebody would pass me by doing 110 plus.
That's funny. I used to drive real fast. Like I would do 70, 75, 80. But mostly traffic would be going with me. Now I've got like the full self-driving on the Tesla we were talking about earlier, and now I just set it, low, and I just relax. It doesn't take me much longer to get to where I'm going. I've taken cross-country trips. I was going to tell you, Zach. I've been taking trips from here to Chicago to visit family back there, and I have family down in Florida. And if it's like east of the Mississippi, I'd rather drive.
Yeah.
I took a road trip down to Texas once that took 2 days, but it's just so much more relaxing than flying. You're not in an airport all stressed out and TSA barking at you.
100%. I'm with you.
I really enjoy it. I like it a lot.
I don't mind flying, but I hate the whole everything you got to do to get onto the plane. It's a pain in the ass, man.
Yeah.
Well, you get to take all your stuff with, too. John and I actually worked at NASA for 6 years together.
Oh, dude,
we were both on site at the same time. We only really worked together a couple of years.
I was thinking about that. I think we worked together like 2009, 2010 time frame.
I know we were. I know it was in 2009 that we were in the mission design lab together.
Yeah. So we worked together for a couple of years and then just been hanging out since.
Yeah. So when I first moved to Annapolis, that's when we started hanging out together. Yeah. Tell us more about yourself.
Okay. What can I tell you? I'm an engineer at NASA. We alluded to. I'm married, have a couple of kids. Been married twice now, and I just enjoy, working, being a regular guy, just working around the house, fixing things, and I like working on cars. I like astronomy. We were talking about your telescope there.
You have a PhD, right?
Yeah, I have a PhD in mechanical engineering. So I got a bachelor's and master's at the University of Illinois in Urbana-Champaign. And that's when I...
Party school.
I remember it was, at the time it was... I think it was a party school. I didn't go to any parties. I was like at the library.
That says something about John.
That's funny.
He's a bookworm.
But you're doctor, so you go by Dr. John?
No.
No?
I don't think anybody's ever called me that.
Yeah?
Actually, except when I want to like give medical advice.
I mean, I think
And
you
then
can
I
pull
say,
it off.
Okay, I'm actually a doctor. Yeah.
Yeah. Excuse me, that's Dr. John.
Or when he's giving you medical advice and they go, "Are you a doctor?" And you go, "Actually,
Yeah.
Yeah, right.
not that kind of doctor, but yes, I am."
Yeah. But so you're reminding me now. When I worked at the University of Illinois, I got a research assistantship to do, research in mechanical engineering, and there's basically a split in mechanical engineering. You can work on thermodynamics kind of things, heat transfer, or you can work on vibration and force and stress and more like stress analysis and things. And I was on the thermal side, and this professor said, "Hey, can you come work for me measuring refrigerant properties?" And at this time, R12 was being phased out of home refrigerators and cars and stuff because it was destroying the ozone layer.
What's R12?
R12. So that's refrigerant 12, Freon 12, the old stuff. that it has chlorine in it. So like when it escapes your refrigerator, it goes in the upper atmosphere.
Didn't work as well as the new stuff? Is that why they were...
No, it worked actually way better than the new stuff.
Why were they phasing it out then?
Because of the ozone. It was destroying the ozone. You remember this in the 90s?
I know exactly all behind this, but not everybody's listening.
Gotcha.
The new stuff, the like 44A, is that the new one? What is it called?
There's a bunch of new ones.
But what makes it work better is the fact that one evaporates more.
I mean,
the thermal variance is wider.
So the reason the government forced you to change is because the old stuff was destroying ozone
when it escaped.
When it escaped, right? And
gotcha.
There's all kinds of new alternatives. Like you can use propane as a refrigerant, but it's flammable. So there's pluses and minuses to every other new refrigerant. But at the time, like DuPont was making this new stuff.
But what makes it a refrigerant?
What makes it what?
What makes it a refrigerant?
What makes it a refrigerant? The temperatures and pressures at which it changes phase from liquid to gas. So like water, at atmospheric pressure, if you heat it up, it'll evaporate when it's at boiling at
it starts to go to a vapor.
212, right? So if for some reason you wanted to refrigerate, let's say you were on the surface of Venus and it's 800 degrees outside and you want to keep your electronics cold at 200 Fahrenheit, you could use water as a refrigerant. It would boil at 1 atmosphere and 212 degrees. It would cool off your electronics, but then you would have to compress that vapor in a compressor and then up at a pressure high enough where it's still a gas at high pressure, and you would cool it down in the at Venus ambient temperature, 800 degrees. It could cool down and become a liquid again at high pressure, and then you expand it through a valve or something back down to low pressure, and in that expansion it cools off into a liquid plus vapor, and then you could heat it up by cooling off your electronics back at 212. So that's called the vapor compression cycle, and that's how most refrigerators work.
Basically, it's transferring heat energy from one location to another.
Exactly. And
then it cycles itself.
Yeah.
The refrigerant is what cycles the heat from one location to another.
Right.
So that's what all that piping on the back of your fridge is doing.
So, the tubes in the back of your fridge are the condenser that recondenses that hot vapor from the compressor, and that goes inside the fridge and gets expanded down in the freezer to those low temperatures. And you can select different refrigerants depending on what your hot and cold side temperatures are. But you reminded me of like Carrier, and those companies were some of the first companies in the 50s to develop these systems for people at home to use and in cars, right? And I was reading about this trucking company in the Middle East, in Syria, and what's now Lebanon. I guess back then was some British protectorate, I forget what, where Israel and Lebanon and all those countries are. They had a trucking route from there into the middle of the desert to over towards Tehran and back. Mm-hmm. And this rich Arab sheik funded this company because he wanted to use those trucks to smuggle gold, from the Middle East toward the Mediterranean ports and then out into the world. So he's smuggling gold on camel trains. And he's like, this sucks. The pirates are robbing me all the time. Security's lost. So I want trucks to go faster than camels and smuggle my gold better. So he funds this company. They build it up. And it's it's 120 degrees out there in the desert. And this company is...
But why does he fund this? So that the trucks can run in the desert?
Yeah. So it started as a passenger company, passenger service, before airplane service.
It's too hot inside.
I think this must have started in the 20s. And so it's hot outside. These trucks are driving through the desert. First, it started with big sedans, like big Packard, 6-passenger sedans, and then they started building buses and large buses that held a lot of people. But the point is, then the connection back to air conditioning was these things would passengers would be uncomfortable. You're driving for like 2 days in the desert. And so they had some of the first air conditioning systems, and I remember this, the guy said it was so nice, they would cool down the inside of the bus down to 90 degrees.
Damn.
Can you imagine? And I thought, like, it's come a long way. Like, now I can pick up my phone and say, pre-cool the car to 65 degrees because I'm going to go in 5 minutes.
I would imagine back then, too, a big part of it would be to get, I don't know, maybe in the desert there wasn't any humidity. But if there was, they could get rid of the humidity too.
Yeah, I mean, people are sweating, and so that humidity on your body helps cool you off.
Yeah.
If the air conditioner is running, but
that's why you want it to be a dry heat, so your sweat actually can do something.
Exactly.
It's like when you walk out of hot yoga and it's 90 degrees outside and it feels great.
Yeah, that's true. That's very true.
I mean, you're like, man, it feels amazing out here.
Yeah. Oh, it's so much cooler.
Yeah.
so
than 110.
Yep.
I started toward my PhD, studying refrigerants, and I had one of the first bottles of this new refrigerant at the time, R134A. It was like my professor said, go get this bottle from this other student upstairs and bring it down to our lab, and you can use it in your experiment. And I remember getting this bottle, and he's like, this is the only one on the East Coast, so don't drop it. And I put it on a bottle cart, and I'm transporting it through the building, and then I have to go down some stairs. I'm like, it's midnight. I didn't think to use the elevator. I didn't even know if there was an elevator in that part of the building. So I take this cart, and I'm like halfway down the stairs with it on these two big wheels. It's like a hand truck, basically, that you chain a bottle to. And I'm halfway down the stairs.
How big is this bottle?
It's a K bottle. So it's a large, the metal bottle
that they use for
I think it's
blowing up balloons at the party store.
The 5 foot tall bottle. It holds a couple hundred cubic feet
of gas. This isn't like for
it's like 120 pounds or something.
This isn't like your SodaStream size
yeah,
bottle.
Right. It's like 100 times bigger than that. And halfway down the stairs, the little back legs on the cart pop out, and so like I cannot go down the stairs or up the stairs. I'm like stuck in the middle of the stairway. Nobody's around. Like, God, what do I do? This bottle is so heavy. I'm tired.
How old were you?
It's midnight. How
old were you?
At the time, I was probably, 24, 23, something like that. And I didn't know what to do. I had to muscle, just kind of like hold the cart with one hand and try to get the bottle down the stairs. I was like sweating bullets.
Because you thought you were going to drop the damn thing?
So I was going to drop it and, ruin it and lose it and never, I wouldn't be able to run my experiment. I couldn't graduate. It was a tough spot. I'm getting nervous just thinking about it 20 plus years later.
So you got it down the stairs, just like one stair at a time?
Yeah, exactly.
Basically,
like one stair. Yeah. I'm like on the side of it instead of behind it, trying to keep it together. I'm like, this sucks.
Yeah.
Some little pin pulled out or fell away or something. A pin was missing. So, but anyway, so I did all that kind of research, and then when I went to, let's see, what did I do? I graduated with my master's. I went to work at Fermilab for a couple of years, kind of out toward you guys in northern Illinois, in Batavia. So there was a large liquid helium cryogenic system there that they were using to cool superconducting magnets in this particle accelerator. Fermilab, the Tevatron or something, I think it was called. They were smashing protons together, and they actually, while I was there, this was pretty cool. While I was there, they found the top quark. So each proton is made up of each particle inside the nucleus is made up of protons, right, and neutrons, and those are made up of quarks. And they're like, the standard model had this.
Zach thought I was an egghead.
Sorry.
No, I mean, no, it's cool.
No, I mean,
it's
you
cool.
Speak. I can understand what you're saying.
Okay, awesome.
So it's
I'm
not like
trying to get you to be
thanks.
quiet about it. It's just excellent.
So I remember now too the
eclectic gentleman. You know what I mean?
So they I was like a small part of this giant organization that. I was part of the engineering staff that helped the scientists operate the machine so they could find the top quark. And the guys won a Nobel Prize from it. And
Damn.
It was a big deal at the time. And I remember I bought a book. Our lab's director, the top guy, he wrote a book called The God Particle. That's what I think that's I'm confusing it with something else. The Higgs boson. It's just some other subatomic particle. I think, I don't know all the physics behind it or anything like that, but he wrote this book anyway. And I'm like, oh, I'll get his autograph, and he signed it for me. And I'm like, lost that book in a move, in between houses somewhere. I keep looking for it. I still haven't found it, but anyway, it's just random memory from the time. I liked working there. I had a really cool group of people. We were working on it was at the time it was the biggest liquid helium cryogenics system in the world, and it was pretty fun.
What are cryogenics used for besides like freezing Walt Disney's head?
Oh yeah, that's classic.
Yeah,
tell me
main use.
about the gigantic facility at NASA.
At NASA, which one are you talking about? Here at Goddard, or
the Goddard? What I'm forgetting the
clean
name
room?
of it. No, not the clean room where they drop the temperature down.
The big vacuum chamber.
Yeah.
That you put the whole satellite in.
Yeah.
And stuff. Yeah. So
they basically simulate the vacuum of space and the temperature.
exactly.
And they use cryogenics to.
Yeah.
That's why. So there's two.
What's the name of it?
It's that big chamber. It's a big thermal vacuum chamber.
The thermovac chamber.
It has a name, like it's like Big Bertha or something.
Yeah,
It has
but we
that
call it
name.
the thermovac chamber.
Yeah, and they have smaller
Big
ones.
Bertha.
This one's big enough. You can like it's like a giant egg that you split in half, and the top half gets craned up high.
It was built for the Hubble Space Telescope, right?
Yeah. You can put a huge observatory in there,
Yeah.
a huge satellite, and test it, and then so they pump down the vacuum because obviously space has a vacuum, and then you can control the temperature of these different shrouds inside. So they'll cool them down to liquid nitrogen temperature, which is like minus 350 Fahrenheit, or down to minus 450 or so. I forget the exact number, but that's with liquid helium. So your whatever electronics box is heating up, and you want to keep the temperature of the satellite all around room temperature. So one side of it will be exposed to the sun and get hotter, and the other side is exposed to deep space or the Earth. And you set up all the temperature boundaries to try to simulate what happens in space so your satellite doesn't overheat or get too cold in certain parts. So that's like about most of the use. But where I started at Goddard was in a technology development area where we were working on sensors and refrigerators that got even colder. So as you get colder and colder, it gets exponentially harder and harder to get colder. So with liquid helium and liquid nitrogen, you can still use that vapor compression process I was talking about before for refrigerators and air conditioners. You can still use that down to about 1 degree above absolute zero, and below that it gets. You just can't do it with that process. So you can actually do it magnetically with certain materials. If you put a magnetic field on them, they heat up, and if you remove that magnetic field, you lower it, they cool off.
Much like the Pelter.
That's different. That's a different kind of. It's also solid state, no moving parts. But the Peltier thing does not use magnetic fields.
You sure?
It's just It's just
when
direct
you put
current.
electrical current
You do
through it,
put
it creates a magnetic
You do
field.
put it. I mean, it's going through the atoms of the material and moving.
Because it's super. It's superconductive material.
No, not those. Those are not superconducting.
I thought the two plates were on top of
They're
superconducting material.
They're semiconductors. And,
Okay.
And I'm not sure exactly how the Peltier works. I mean, you basically put electricity through it, and it moves heat to opposite sides of the crystal, and heats up one side and cools off the other side of the crystal.
Depending on which direction the electricity is flowing, depends on which side.
Yeah, you can
of it.
reverse them. They're nice. They're fully reversible. But
So-
the problem with those is they're solid state. They're super inefficient because that electricity moving through the crystal generates heat, and that leaks into the cold side that you're trying to cool off.
So the cold side doesn't get as hot as the hot side does because of...
It's the physics. You could just look it up on Wikipedia. I don't bother to memorize half the how things work anymore because you can just look it up on
Well, you've got a
YouTube or
supercomputer right in front of you
your
on
phone.
Yeah.
Siri can tell us.
Yeah.
Wait,
So.
that's life is an open book test. You don't have to memorize any. It's all
Yeah,
open book.
Exactly.
Yeah.
You always have it.
Yeah, the Victorian way of teaching was based on memorization, which we don't need anymore.
Yeah.
Yep.
In fact,
was-
a lot of the engineering department that I work in still is based on the way that they do things is still based on memorization, and they're constantly wanting to name things in a way that they can remember what they are. And I'm like, you guys all have a computer on your desk. You don't need to memorize this stuff anymore.
Yeah.
Like you don't name photos on the internet something cat photo in order to find all the cat photos. You put in a search for cat photos, and it doesn't care what the name of it is. It comes up with cat photos.
Yeah.
And so, yeah, there's a lot of ancient Victorian processes that are still going on that people don't realize
Yeah. It's
are
weird.
outdated and have been since the 80s.
Yeah. Do you remember when you were a kid you had to memorize phone numbers?
I was very good at it.
Yeah.
I would like tell people that their parents' phone number, we'd be out and I'd have all my friends' phone numbers memorized.
What was your phone number growing up in your house?
I still have it today. I'm not putting it on the air.
788-7471.
Yeah, see?
Yeah, that's...
Yeah.
I don't
But-
remember mine. I got.
Do you remember the one your parents had at your house when you were a kid?
No.
You don't even remember the last four digits?
No.
Ours was
Dude,
43.
I barely remember what town we lived in.
Ours was
I had to think
438.
about that.
Yeah.
Yeah, I mean, just why? Why bother? Why bother mental energy remembering stuff like that?
I don't-
anymore, you know?
I don't think
you-
about it for
yeah.
decades, and it just pops up in my head.
Although I did memorize pi. Like I was like bored in school, and I would memorize digits of pi, but not that many. But
So
I do
pi
remember
is
some of
important to
that.
you.
yeah, it could be. Well, but anyway, so let me finish my story about the thing at work. So at NASA, I was working on a refrigerator. We actually, so this magnetic refrigerator, we at the time we used it to cool off a detector that could detect a single photon of X-ray light. It was XRS.
A single one?
A single photon. So, like now, there's camera sensors now that can detect a single photon. I think at room temperature. Well, anyway, I'm getting outside of my field.
What's the
but
difference between a visible photon that our eyes can see and an X-ray photon?
The wavelength. So the photon is a
Just
wave.
The speed at which it's
Yeah.
oscillating?
Yeah, the frequency at which it's oscillating. So visible light is like 500-600 nanometer wavelength,
Mm-hmm.
and an X-ray I think is much shorter. I'm not sure, like it's like 1 nanometer, or some much smaller than that. I'm not even sure, but with the shorter wavelength, the energy is higher, so it's easier to detect and measure a single photon. But they had these crude detectors with maybe like, I don't remember, like 36 pixels or something, and they could detect a single photon of X-ray light. And that's the satellite that we launched, and that had a really tortured saga. Like 20 years ago, I helped build this first one. Actually, I built the second one. The first one failed on launch. Like the rocket booster had a problem. They had to blow it up because it was going off course.
Damn.
They launched ours, and we operated for a couple of weeks in space. And at the time, we set the low temperature record in space, like 28 or 29 millikelvin. So 29 thousandths of a degree above absolute zero. That's how cold we got the refrigerator. And then just a couple weeks after launch, we lost all of our coolant. The magnetic stuff was still working, but it had to dump heat into liquid helium, and we lost all the liquid helium. And then they launched it a third time. They rebuilt it a third time, and the spacecraft accidentally spun up to dozens of RPM and flew apart because of a software error in the software code.
Was that one of the thrusters that wouldn't go off or something like that?
The thruster thought it was slowing down the rotation, but instead it was speeding up the rotation. So they went into a safe hold.
So
They
the
had
more
some,
it would go on, the more it would go on.
yeah. So they're like, hey, slow down, and instead sped up. So I mean, it happens. You learn from that. And then you write rules to, okay, next time we build a satellite, check the code. You can check for that stuff on the ground before you launch it. Do I have the plus and minus sign in the thruster
That's what always
direction?
blew me away about things getting into space where you can't actually work on it.
Yeah.
And like just the grinding of the Hubble mirror.
Yeah.
I never understood how this stuff got into space.
That's my favorite part. Go ahead. Oh, go ahead and finish.
No, go ahead.
My favorite part of the kind of engineering I do is to look at like when things fail like that, why the Hubble was ground to the wrong prescription, or why this satellite spun up instead of slowing down. Those mistakes, they're like innocent, honest mistakes. Just people are working and they make a mistake, right? Or they're in a process which is not a good process and doesn't double check people.
My favorite one is when these missions that they put together for a decade would go in and impact on Mars because of the conversion between miles and kilometers.
That's the classic one. I'm glad you brought that up.
I think it happened more than once, didn't it?
No, well,
I know it happened once.
That you're talking about. I think it was Mars Climate Observer. That's the one you're talking about.
Yeah,
and that is like the most interesting one to me. I'm so glad you remembered it, because everybody says that it was the mistake converting units, and that's not actually what happened at all. Not at all.
What happened?
So the way that happened was JPL was building that satellite, right? And at the time they were in this process called better, faster, cheaper. So, just work smarter, work instead of hard, whatever, missions were getting expensive, and they're like, okay, we're just going to staff less people and work them harder, is essentially what they were doing, right?
Yeah.
So the engineer in charge of that, of that particular system, I don't know specific details, like what did the engineer think or say or do, but I'm saying like they were really overworked. Okay, so you can't double check everything.
Yeah.
Now, having said that, it wasn't their fault. It was the subcontractor's fault in the sense of like, they paid a subcontractor to calibrate some thrusters. Okay, some hydrazine thrusters. And they bought the thrusters, and they bought the calibration tables. Like, when you pulse it on for a millisecond, here's how much impulse comes out of this thruster, right?
How did they measure the amount? Was it based on distance?
I'm not sure how you calibrate a thruster on the ground, to be honest with you. You probably put it on some balance beam or something, and you can measure the impulse. But in any case,
like the PSI?
Like, I think you would...
Like a force gauge?
Similar to a force gauge, yeah. You measure force integrated over time to get the impulse.
Okay.
And so we paid, $1 million to this company, and they delivered the thrusters and this calibration table. Okay, 1 millisecond is this much impulse. 2 milliseconds is that much impulse. Because you want to know these things very exactly, so you calibrate them. And the engineer gets this data, and he's like, okay, it looks good. And, move on to the next thing. The problem was, when you calibrate these things, they didn't include the units. Like if they say, okay, 1 millisecond is 32 value of impulse. Well, is it 32 foot-pounds per second, or is it 32 millimeters newtons per second, or whatever the unit is? They gave it to us in one form they gave it to us in English units. Okay. And the English unit is nearly the same. It's like a factor of 4 or something different than the metric unit. So it's not obvious, like, oh, it's not a million times bigger than the value you expect. It's in that range. And we accepted it. We programmed it into the satellite. And so this little thruster, we wanted to thrust, 1 impulse, but it's impulsing 4 from the software commands. Okay, and they knew that something was wrong too. They could tell as it was going out to Mars, it's essentially drifting off course. Why is it drifting off course? So they were having meetings, right? And they were trying to figure this out. And these were small, I think these were small, little tiny thrusters just to correct a small course change. They had, I think, a bigger thruster that, you would do the main big burns with to get into Mars orbit or whatever.
Mm-hmm.
And so these errors were accumulating, and they're like, okay, let's, fire the thrusters and correct the course. And they did that several times.
Do you know what year this was?
This was 99, I think, 98. Do you know what year the Columbine shooting was?
2001, I want to say.
Okay, I think you're right there. And the reason I asked specifically about Columbine is because the company that built the spacecraft is in that area of Colorado, and they were having meetings this is the last big meeting we have. We got to decide what to do, and then we got one more chance to correct the course of the spacecraft. And so they were going to have this meeting that day, and then the Columbine shooting happened, and they're like, okay,
April 20th, 1999. You were right.
99.
Yep,
Okay,
you were right on the money.
So obviously they canceled the meeting. People in the area, went home to take care of their kids and things. And so my point is this was like a small mistake back in the, and if technically, so nobody converted feet to meters. There was no error in, calculating the metric to English conversion. It was, I handed you a sheet of paper and I assumed you wanted English units, and you took that sheet of paper and you assumed I used metric units, like was specified in the contract, by the way. That was the subcontractor's fault. And, our guy should have checked, or the JPL person should have checked those units. Or, simple question, what units did you guys use? Like in 3 seconds, he could have avoided all that. But, the dude's got 45 other things he needs to do now because of this better, faster, cheaper architecture. And
they did it in English, or they did it in metric?
They measured
the calibration
calibration measurement was done in English units, and our guy expected to be given a table of metric units, and that's what the standard boilerplate in every NASA contract says. Use metric units.
I believe the reason why this expectation goes on is because the scientists at Goddard Space Flight Center work in metric, and the people building things work in English. This is still a day-to-day thing that happens, and I don't understand why that is, because I used to understand that metric. Well, I used to think the same thing that a lot of people think, is that metric is eventually going to be what we all convert to. But as I've gotten older and more involved with manufacturing, I understand that the only real benefit that metric has is it converts into larger forms by a factor of 10.
Yeah.
And on the manufacturing floor, it is not as great a tool because it's not divisible by as many things and usable in the manufacturing. What do they call an operating room? I can't remember what they call it.
Like a machine shop?
No, like
surgery
in the theater.
Yeah.
If you're in a manufacturing floor,
yeah,
there's a lot of advantages to using, inches and decimal places because of the way that just look at the difference in tolerancing, right? Mm-hmm. And a lot of people don't understand that. Anyway, I think it's interesting because it was probably a scientist who was reading the calibration table that was provided to him in English, and he's expecting metric because both of these guys are working in what they work in every day.
Yeah,
and they're truly not communicating.
That's the problem, is the communication. Like it doesn't matter. You could create a whole new system and whatever goofiness, for whatever reason. But as long as we all are on the same page, we can work through it,
Yeah, I mean, it didn't change the forces of the thrusters.
Right.
It just changed what you understood the forces to be.
Right.
And you'd learn the right questions to ask the next time.
It's always like 42, right? It's all about the question.
Yeah.
It's not about the answer.
That's still a big deal too. Like many years later, people are like careful about the units, and whenever big problems like that crop up, like the Hubble mirror and stuff, because we don't have infinite time and money to get it absolutely 100% correct and double and triple check. There's just not enough time or money.
Well, I think you put your finger on the pulse of the problem, which is communication. Like, I know a lot of. So I'm still at work. I'm still pushing model-based definition, and I literally get very young engineers, 22, 24, that will tell me that they very much prefer drawings. Well, preference means that you've actually used both processes. And I know that they're 24 and they haven't really had a chance to really use either one of them, because even in college they don't learn blueprint reading as part of their courses. And I know for a fact that they've never sat down and used CAD for more than a semester. So this communication that he's giving me about his preference is based on very negligible, like, actual utilization. And a preference that would matter would be like you utilize it heavily, and then you utilize the other thing heavily, and then you have a preference, and then that matters. So it isn't necessarily that he shouldn't have preferences. It's that we should communicate more granularly with higher fidelity. Like, what led you to believe this?
That takes a lot of time and effort to communicate.
And everybody's always trying to boil it down to...
I
agree with you.
I think about many things while you're telling that story about the engineer's preference to use one thing on his experience based on, what did you call it? Valid, right? A valid experience, valid preference versus presumably not valid preference.
Well, I think they're both valid depending on the scale that you put next to it, right? If you're asked about your preference at looking at two items within 10 minutes and everybody understands that you've only had 10 minutes to look at it, then that's a valid preference. But if you show up to a meeting where there's people who are literally twice your age and they have a preference and you have a preference, we need to make sure that everybody understands that those two scales are completely different. Like, this guy who's twice your age has literally spent your entire lifetime in a machine shop using this. So whose preference should be more valid? Who's used it longer?
Yeah, no, I get your point. I'm just you bring up so many other areas going to that. It's like you're whose preference should you use should be like, in a hierarchy there's a boss and a subordinate. Like, then you should probably use the boss's preference unless the subordinate can change the boss's mind. If your colleague's on an equal level, it's a tougher question.
Well, I wouldn't even go to boss and subordinate. I mean, somebody has to shoulder the weight of the decision, and so I get that. But it should all be based on merit. And so I'm not actually saying that the guy who is less experienced shouldn't be listened to. What I'm saying is that you need to make sure that the scales of both of their preferences need to be weighed against each other. Like, this one kid could have 20 minutes or a year of knowledge of this completely new technology that this 40-year-old in the industry has no experience on it.
Right.
And so now he's got a year. He's literally got 1,000% more experience with this new technology than anybody else in the room, even though he's 24. Yeah. And in that particular case, his preference should have a higher weight. So it really is like, what's the scale? What's the scale of your preference compared to my preference? We need to talk about that.
Yeah.
Not just assume that because you're younger than me that you don't know what the hell you're talking about.
Yeah. It's like saying you don't like broccoli. I mean, you never tried broccoli, right?
you shouldn't like broccoli, clearly. Broccoli's terrible, in my experience. No.
Yeah.
But
fun fact, asparagus and broccoli are basically the same plant.
Both green. No, but I just want to say, like, if you're going to decide which preference to go with, and each side, presents their case, like, we should do my way, no, we should do my way, you typically, if there's not a boss who says, okay, my way or the highway, if your colleagues trying to have a debate about it.
Well, if you're trying to actually come up with the correct solution, not just somebody's preference, one person's preference, what is the correct thing to do?
So you can list out. You can list out. This is very good because I spend a lot of my time thinking about how should I do something, right? And then there's like 10 ways to skin a cat, right? So you can list out the pros and cons of each way of doing something. And when I'm by myself, that's great. I decide and I do what I decide to do.
Yeah.
But if we have to work together, then we can communicate like, hey, listen, I know you've been doing this for 40 years, but the advantages are A, B, and C, and of course the disadvantages are D, E, and F. But if you can live with those, we'll get A, B, and C. And you'll say, no, well, I think you're overstating the advantage of A. It doesn't matter in this situation or whatever. But see, that takes time, and then our egos get involved because I want to be right and you want to be right.
Mm-hmm.
You like to be right?
Well,
I know I like to be right.
You do like to be right.
I love it.
I even admitted to him earlier today. I said, I know I like to be right.
Well, that's Where do you want to put your mic stand? Well, that's one of those.
What's your
conversations.
preference?
Yeah.
There's a big difference though between 20 years of experience and 1 year of experience 20 times. Yeah, right? Because sometimes experience doesn't always translate into knowing more. I've just been doing the same thing for 20 years. But
And
it depends. That's why I use the phrase scale. Like you need to understand the scale of what the preferences that you're talking about. So maybe the terminology preference isn't appropriate in an engineering environment.
Mm-hmm.
Maybe it's just not appropriate at all. But then you get people who come and basically ask the same exact question: what's the return on investment? Well, I'm doing a feasibility study. What makes you think I have any idea what the return on investment is yet?
Mm.
But does that mean that we shouldn't do feasibility studies on new processes? Probably not, because if we're not innovating, then if you're not growing, then you're rotting. You know what I mean? Anyway,
Yeah.
we've always had very interesting,
deep philosophical.
So
and we're not even disagreeing. We're just like exploring different parts of the.
But I feel like your example is stemmed from reality. So did you convince the 24-year-old to do it your way?
No, I just pointed out his flaw in his logic.
Yep.
To everybody, so
in front of a room full of people.
You just shamed his ass.
Well, I had to, because he did the whole preference thing in the room full of a bunch of other people, as if it mattered, and the way that he stated it, and everybody kind of looked at it and said, "Oh, okay," and then I had to point out how much his preference didn't make any sense, so that nobody in there put any weight in his preference. Because he was an engineer, and I was a designer. And I'm like, okay, well, I'm a designer, but I've got literally like 40 years of experience, and you've been on the job for 2 years. And you've also never used this other process that I'm talking about. So I don't even know why you're saying anything, is basically what I said to everybody.
He probably got home from work, and his girl was like,
No.
"How was your day, babe?" And he's like, "I'm just going to play Call of Duty tonight. Fucking Heath." Yeah.
No, I'm pretty sure that guy
Kicked his
couldn't.
dog.
I'm pretty sure that guy didn't even remember my name the next day.
Yeah,
he,
all right.
he literally. That was the other thing too, is he, pretty much looked down at me, and so, yeah.
Yeah.
A lot of the engineers, a lot of the degreed engineers that I've worked with over the years, don't do engineering. They get hired. They work with the database softwares that the company uses. They work with company-specific tools that have nothing to do with engineering, and they push like part numbers and ECNs, engineering change orders, and they don't really actually do any of the engineering equation work that they actually went to school for. They process the project. They become a project manager and whatnot. And I think that's one of the reasons why John enjoys what he does, is because he's actually calculating things that matter, right?
No, dude,
No?
I have not done real engineering for a long time. I just had this conversation with my wife, and she's like, trying to explain to somebody else what I do, and she's like, "What exactly do you do?" It's engineering, right? It's a kind of engineering. I'm like, no, not really. Like I haven't calculated.
You don't do stack up analysis on thermal variations?
Nope. No. So
you did when we were in the mission design lab, though, right?
I did before that when I was doing technology development. I think the last real engineering I did was for that XRS mission, XRS-2. I developed superconducting current leads for the magnet, and I did do some calculations and some math, and dude, that was 20 years ago.
Would you prefer to get back to doing some engineering?
Well, I do that as a hobby now, like in the home garage with my cars, and I do.
So yes, you'd like to be doing some engineering.
That's what I do for fun, because like, and I, I love my NASA day job work, but that's not. It's a type of engineering, but it's not in the sense that you're talking about with like calculating things. I don't calculate anything, right? I make sure that when you're talking to him, you guys are speaking the same language. This is another thing. I love those lessons learned from previous mistakes that we were talking about earlier, the metric thing.
Reducing human error.
So when two people are talking in front of me, like it's some whatever highly technical. This happened the other day too. This happens about or not once a month, but maybe like five or six times a year. I'll be in a conversation, and I'll hear somebody say, describe whatever thing to a second person, and that person will respond, and with his response or her response, he's responding to something totally different than what the first person said. I'm standing there listening to both of them, and they're like completely talking past each other, and they agree. They're like, okay, we're good. Okay, let's go. And I'm like, wait a minute, hold on a second. And then I'll clarify the situation, and they're like, oh, really? Okay, thank you. Okay, then totally misunderstood you. Let's, the conversation continues. I'm like, that's like perfect. That's another really, high value thing that I do in my work is when two engineers are agreeing to something or communicating, and they're miscommunicating. And I do this all the time. I'm, terrible with words, but that's a skill that I have is
I agree. It's very important
that, and
yeah, I agree.
So that's the other fun thing. So basically, I'm not doing that like the math and calculation of things. I can, I'm pretty rusty at it, but I do more of like a technical management of like I write documents that are basically agreements between the spacecraft and the instruments, or between the integrated observatory and the launch vehicle, and or how is our spacecraft going to communicate back to Earth or receive commands from the Earth. That's really complicated. I mean,
I think a way for everybody to understand what he's talking about, and please correct me if I'm wrong, is John manages different disciplines and makes sure that they talk to each other to guarantee the life cycle of the entire project.
Yeah. That's accurate.
A coalition of what you're trying to express?
Exactly. Yeah. So typically a NASA satellite is either a scientific research satellite with instruments, right? And in many cases, the scientist is in charge. She's literally the boss of the mission, the principal investigator, and NASA.
What's a principal investigator do?
That's the scientist who won the proposal. Like the scientist proposes, we're going to explore the moons of Jupiter, this certain,
or go out to this comet and take a sample.
Exactly. Yeah, sample a comet. The principal investigator, the PI, writes a proposal to NASA, and NASA selects the proposal and awards them, $100 million or whatever, and then assembles this team of people who design and build and launch and operate the satellite. So a science satellite, the principal investigator that's a type of one of those science satellites can be managed by a scientist like a principal investigator. And recently I was just involved with the PACE mission, the Plankton Aerosol Ocean Color Ecosystem, I think. I'm not sure about the acronym, but PACE. It just launched. It's a really cool instrument. It's got a hyperspectral color camera, which it'll measure like the exact.
Is the C for
wavelength.
carbon?
The C is
For how much carbon
ocean.
dioxide has gone into the ocean?
No, it's not carbon. It's like the second letter in the word ocean, is what the C stands for. in
Okay.
case. And it's a color camera that it's like see that image on your TV right now. There's like a river and it's different shades of green and blue, right? From the plankton and the animals and plants living in that water. You can tell the species of the plankton and how much is in there if you calibrate that exact color.
Yeah.
Damn.
And so they're measuring. So it's studying carbon in the carbon cycle of how do these plants and animals in the water.
Why did you bring up PACE again?
PACE was for that was a PI-led mission, I believe. I can't remember the
Principal
scientist's name, but
investigator-led mission?
Principal investigator led that mission, and it just launched. It's a really cool satellite that's going to, help build climate models more accurately. So, whatever math model you want to use.
How does it do that?
So it's those models that other scientists build of how the Earth's temperature and climate changes. Those models are fed by, or they're based on, real physical processes and real data on Earth, right? So if you want to make an accurate model to predict the future or to back test the past.
But specifically, what does the plankton or the type of plankton have to do with the data for the model?
All right. Okay. So the plankton is if it's a plant, it's consuming the carbon dioxide and giving off oxygen, right? So it's removing carbon dioxide from the atmosphere.
Okay.
And then those little plankton, I think they die and they fall to the bottom of the ocean, or they get eaten by an animal plankton,
like a whale,
or a whale, and that whale is releasing carbon dioxide back into the air. So the point is to measure, where is that carbon dioxide going? Is it going back into the air? Is it going into the depths of the ocean? And that carbon dioxide affects the temperature of the Earth. How much heat remains trapped in the ecosystem.
Does PACE only track this spectrum in the water? Or does it also do cloud density and other things?
It does. That's the main purpose, is to measure the color of the ocean, basically, to a very high precise way. There's other instruments, and I'm glad you brought up clouds. There's we'd have to look it up. I can't remember. I feel bad because I used to work with this guy. It's a microwave radiometer, a polarized. I think it's measuring polarized microwave light. So I'm getting way outside my memory here, but it's measuring cloud density, and it can tell you like how much water vapor is in this cloud, or is this a cloud made up of smoke particles, like from a forest fire? And it's measuring like the size of those little particles in the air, as if it's a water droplet or a smoke particle.
Okay.
Those are different sizes, so you can infer what this thing is made from. And
so
then,
it's a spectrometer. It's actually looking at the material density.
it's a polarimeter. So I think the light
I've
that
never heard that term before.
light that reflects off of something becomes polarized, and somehow they're measuring like how much it's polarized, and so they know the size of the particle.
Okay.
We'd have to look this up, but
That's great.
But you can that's also important because when sunlight hits the atmosphere, some is reflected back out into space.
Especially when there's more clouds.
When there's more clouds, or I think if it's a smoke cloud, maybe that smoke cloud absorbs more heat or less heat, and so the thermal
because
balance,
the particles actually aren't as reflective as vapor.
Yeah, I'm not sure, to be honest with you. Like all,
But were you going to say PACE has a?
PACE has two smaller instruments on board, which are these kind of polarimeters that. So the main thing is this color
to figure out what the atmosphere is made of.
Yeah, what are we looking at in the atmosphere? And it's in this neat orbit that sees basically the entire
like
Earth.
This image right here.
Yeah,
like everywhere where there's white clouds, all of that sunlight gets bounced back into the
back out into space. So the thermal balance, and then when a volcano erupts, it gives off all this ash cloud and everything, but it also gives off a lot of sulfur dioxide gas, and
isn't one of the theories of the mass extinction of the dinosaurs that super volcanoes all over the world erupted and covered the planet in a big gigantic cloud?
I think that was a meteorite, right? So a giant.
Yeah, I thought the meteor actually ignited volcanic activity with the super volcanoes all over the planet.
Well, no, they found fragments of this meteorite. It had whatever radioactive element, I forget the element, but they found like debris from the meteorite all around the entire Earth. I'm not sure if it triggered the volcanoes or not, but in any case, the ash cloud was enough to make, change the climate much colder for long enough to kill off dinosaurs, and this last one. So yeah, I mean,
but it'd be interesting, right? Based on what you were saying about the cloud. I mean, if it wasn't made up of water vapor, does it actually collect more heat, or bounce it out?
Yeah, that's the point, is to find out, and it's the little aerosol particles in the cloud or in fog or whatever else is covering the Earth.
How many PACE satellites have you worked on?
PACE there's only one PACE, and that launched, I think, back in February.
I thought there was at least two.
The thing I'm working on now is a pretty cool project called the L1 series. It's a group of satellites we're building at NASA, but we're going to hand over the keys to NOAA, and NOAA's going to operate them like they operate the weather satellites, the GOES system of geostationary weather satellites. Like, we built those and we launched them, and then we hand them over to NOAA.
Who's we?
NASA.
NASA's all, but which? I know that it's Goddard, right? Goddard does most of the environmental stuff here in Maryland.
Yeah, Goddard does a lot of Earth science.
The Kennedy Space Center doesn't really do
the different
environmental
centers
satellites.
Specialize. Yeah, Kennedy specializes in launching things.
Yeah, most people don't know this. Is why I'm asking you.
Yeah, it's good. So Kennedy specializes basically in launching rockets. They have the launch range of many pads and the whole infrastructure there. Human space flight leaves from there. And then other centers like Goddard is an Earth Science Center. That's our specialty. Jet Propulsion Lab generally does interplanetary space, exploring Mars, Venus, Voyager spacecraft. I think we're JPL.
So solar system though, right?
Yeah.
Not like Voyager.
Voyagers did the solar system tour, and now they're just outside of the solar system.
Did JPL have something to do with Voyager?
Yeah. I think they built it there.
Okay.
And then, in fact, I know they built it there. I worked with a guy. I worked at JPL briefly before I came to Goddard, and this guy worked on one of the Voyager spacecraft. It had like a stuck. No, not Voyager. Was it Ulysses?
What's the difference?
It's a different spacecraft. This
I
guy,
knew that.
Ulysses studied the sun, I think. There was another one.
Well, that makes sense.
It was a Jupiter. I'm sorry, I don't remember the name, but he worked on one where, like, the antenna, this umbrella, basically, that unfolds to become a radio antenna. This umbrella got stuck and didn't open most of the way. Like, they couldn't get any data. They got a little bit of data back from this thing just because, the grease on the pins.
I'm still surprised that James Webb actually opened.
Yeah, that was amazing.
Because of all of the delays and all of the problems we've had over the years, I thought for sure this is way more complicated than people realize. Just mechanically.
I thought the same thing.
Just mechanically. I'm not even talking about the payload and the science and all of that. I'm just talking about the engineering and getting the thing to deploy so you can actually use it.
That was a real home run. I mean,
I am blown away that it worked.
They put like the best people. The A team really was working on that, and I was worried just because if you're familiar with the design, there's like
all the things that we've seen fail for pretty much not much of a reason over the years, like just not talking like what you described earlier, about the calibration units not being on a piece of paper.
Yeah,
nobody did that on purpose.
So for James Webb, Webb was a flagship mission, right? So you put your A team on it, and then you take less risk. So this better, faster, cheaper approach of the 90s is like the quick, easy way. You can knock out like 4, 5, 10, and have 1 or 2 or 3 of them fail. But if you can't fail, like for human space flight, space shuttle, the Orion space capsule, all those things, that's like we take the least amount of risk, and that's the most expensive. You have to have more people double checking each other's work. And that's what that was on James Webb. But I heard things like just friends of friends who were working on that mission. I heard like some concerning things that.
I worked in the instrument design lab too, and I would see the anti-logic coming from people. That were clearly not. And I'm not trying to insinuate that it was ever malevolent in it anyway. But people would get really, really agitated about, no, we got to do it this way because this is more logical. And I actually have worked in a machine shop since I was, like a sophomore in high school. And I would just go, there's nothing about your approach that is anything less than less safe. Like, we need to reduce risk. And I'm like, everything about what you're talking about actually increases risk. So I don't know. Sometimes I just don't. Now when I look back at it, I go, well, what was the communication fail? Because they weren't trying to be difficult. But so what the hell was the communication fail? Why were they hell bent on doing it this way? When if you had like a practical understanding of what they're talking about, it's obviously not less risk. People would be like, well, less joints in an arm means there's less risk. I'm like, no, that's not true. If you have every joint in the arm, regardless how many they are, if there's no redundancy, then every joint is a risk. But so basically you can't say one thing when really is well, if we're going to have joints in the arm, then every joint has to have either double or triple redundancy to reduce risk. You don't reduce the number of joints to reduce risk. You double the
risk.
The redundancy.
Risk is really hard to. Risk is a complicated like.
Well, it would be like saying I can expect more heads if I get 6 tails in a row of flipping a coin.
I mean that's
statistically. The number of joints in there doesn't mean anything about failure. In fact, quite the opposite. Because if you have one of the joints that fails, and now you can still do 90% of what you needed to do with the existing joints.
There's redundancy.
Right, and so they would say, well, we need less joints in this arm to reduce failure rate. And I would be like, well, it actually works the other direction. Because now you can do, with one joint, let's say you only have one joint, then your arm is basically worthless, right? So if you have 4 joints and one fails, you can still do 60% of what you normally would do.
Right.
And so this is what I'm just sitting there listening to these educated people talk past each other about what the real risk of the whole thing was. And I found it funny that we were in an instrument design lab doing a 1-week study, and we were having that level of miscommunication. Like, that's here tough. We are spending this amount of money, and the people in the room don't understand how to talk to each other.
I think that's
why John was. I always thought John was such a good leader in those meetings.
Well, thanks for saying that.
Well, and what's his name? John, the older gentleman too.
I forget his last name. I know you're John Martin.
But like you were saying earlier, both of you guys, you would both make sure that everybody was actually talking to each other. Because I could see the wheels spinning. You'd be looking at each other like, I don't think you guys are talking about the same thing.
Yeah, you're talking about the Instrument Design Lab, and also the second similar place was the Mission Design Lab.
Yeah.
is an organization at Goddard where you have a scientist come in, and he basically hires a room full of engineers for a week to detail design his idea from, bare bones concept into
Cradle to grave.
Realistic, yeah.
Yep.
So for whatever, it's basically a hired team to develop your concept. And in a week, it's a very short time. Like a typical
It wasn't even a full week, yeah.
Yeah, because you got to report out and stuff. But I forget how many. I think it's like a tenth. It's basically a tenth of an FTE or half of a full-time equivalent of labor in a week, because you have 20 people or whatever. And anyway, my point is, it's a compressed time, high stress kind of environment. Because if you're still talking about the number of joints in the arm on Wednesday or Thursday, you got to settle that discussion Monday or Tuesday.
You really
Or
need
you
to come
get
to the
bogged
Instrument
down.
Design Lab with that discussion already worked out.
Yeah. So
Because you only have 3 days to actually do everything.
yeah. So people tempers flared, and many times people would get very upset in those kinds of environments, and so the people who could set aside the ego or whatever, say, okay, fine, we'll do it your way, or come to compromise better, or communicate more efficiently, faster, to come to agreement. Those people did better, and it's really tiring. Like it's mentally taxing, like to communicate and try to make understanding where people are talking past each other and those things. It's but you get these really great concepts, and people take those concepts when we're finished in the design lab with their proposal, they put it in a real, like, big 150-page detailed proposal, and then that wins a bid for hundreds of millions of dollars, and then gets built and launched and orbiting and sends pretty pictures back from space.
It's a micro. It's a very well detailed. I didn't realize at the time that we were working it, but with the reading I've been doing the last few years, it really is. I think Jordan Peterson, to me, said it the best, and it reminded me of the Mission Design Lab. You go through these ideas and you play out these simulations, which is basically what we were doing, so that the simulation can die instead of your satellite.
Yeah.
So that you don't put up a satellite and on launch it comes apart because it vibrates itself to death, which has happened, or the calibration testing for the thrusters are wrong, so it impacts on Mars. You work all those kinks out in the theoretical, and that's one of the reasons why I got into CAD, is because you could model all the theoretical in a perfect, pristine environment before you start making anything.
Yeah. CAD is really precise. You can draw things and
mass accuracy, density, all that stuff can be included.
Yeah, but then I forget, this from a long time ago, somebody said all models are wrong and some are useful, right? You can't make a model to describe anything complex like climate, or predict the future climate 100 years from now with a model. Now it's super difficult and inaccurate, right?
I agree with that, because anytime you put a simulation together, have you forgotten a variable?
Yeah.
Like, from what I understand, most of the climate models don't actually include clouds.
I don't personally know the detail.
I don't know either, but I've heard this come from a couple of different sources. And if that's the case, it's really disconcerting, since clouds have such a big influence on the sun being penetrating, thermal being collected.
You can take your model, though. Here's what you can do, though. If you have a model of, say, climate, I believe what they do is they back test it by, like, how the climate's evolved in detail over the last 300 years.
Yeah.
So you can start your model from 300 years ago and see if it predicts where we are today. And I don't think they go hundreds of years into the future or past, but
Don't the ice cores take us back 10,000 years?
dude, I don't know.
I don't know the reliability though, but I've heard that
here's the problem. Once like something gets politically controversial,
it's hard to tell what's real
then
anymore.
then the quality of the news and the data that you read just
conversation
goes to pot.
Yeah.
So and of course we want to do the correct thing, and we don't want the earth to get overheated, and we also don't want to spend a lot of money on green initiatives that won't help, right? So either of those things would be bad. And so what's the correct thing to do? There's actually, in my mind, like, so my position on that whole question is like, it's bad for the earth to get much warmer, but I think our technology, I'm a big believer in technology, helping people. I think our technology will mitigate those negative effects, right? So
I mean, like air conditioning?
Yeah, like when things got hot, we invented air conditioning and whatever. But,
I agree with you.
But that won't work for the entire earth, obviously, in a future where, like, let's say 90 degrees is a cold day. Well, that would suck,
Yeah.
But on the other hand, I think, like, are we going to be burning coal, or how are we going to be living 100 years from now? I can't even imagine.
Well, I'm pretty sure that you and I agree on this, that the thing that is actually controlling the temperature of the planet is the actual thing that gives everything life and everything power, which is the sun. Everything is solar based, from the food that we eat to
almost everything. I mean, there's things at the bottom of the ocean that live that don't get sunlight, but the sun clearly has the dominant influence on the temperature of the planet, sure. But we as humans have certainly modified the environment.
Yep.
Right. And I think a lot of people get spun up about, like, should I have a gas car or an electric car, or am I doing something good for the environment or bad? Or, is this the wrong thing to do, or is this the right thing to do? I think, on an individual level, do whatever you want. And, I'll be fine with if you do whatever you want. I think for me personally.
Why are you fine with that?
It won't. Well,
no, I'm not disagreeing with you, by the way.
No, sure. I think I'm a big believer in personal freedom and independence and responsibility. I personally would like, less government in my life.
Why is that?
Telling me what to do, and because I'm independent and I like to be responsible for my own outcome. I don't want a big government coddling me or I'm just not. That's not how I like to work. But to get back to,
I agree with you.
I think if you want to burn a lot of gas in a car that gets 2 miles per gallon, knock yourself out. I think, or if you want to ban gasoline cars or something, then go for it. Try to do that. But I think in my lifetime, I'll be fine myself and take care of me and my family and people close to me. I think we'll all be fine, and whether the climate changes by half a degree higher or lower won't matter.
Isn't it better for things to be warmer than colder anyway? The cold kills more people than the heat does.
Yeah, see, that's one of the I heard that too recently. One of the politicians, Vivek Ramaswamy, was saying that, and I thought at the time, I like the guy and he's smart, but I think he's wrong. I'd have to look into it, but okay, when you say cold kills more people than heat, okay, I think if you count the number of people who freeze to death versus the number of people who die of heat stroke, is that what he's doing? Where does that number come from? What's the basis of his statement? right?
Yeah.
And that's one thing.
Like cold weather.
you know, whatever it is.
Like if your air conditioning were to go out, you're not going to die. But if your heat goes out, you might die.
Yes, that's true. But
that's where the statistic comes from.
Here's my problem with what he's saying is, he has some basis. He's got some statistic that support that statement, right? That's fine. And it could be accurate and true. My problem is that's and I like the guy personally. I think, he has many smart, good positions, but on this particular one, that's kind of like a soundbite. I was thinking about this within the last week. That's like a little soundbite, to jab at the Green Initiative, right?
I think it's just trying to boil it down into the space that they give for response. But
yeah, in a soundbite.
But that's a soundbite, yeah. So, but I'm just saying, I don't. Go ahead.
I got the stat for every. Hold on, where was it? Yeah, for every one death linked to heat, 9 deaths are linked to cold.
Yeah,
according to a 2021 study.
That's a big change. Now, so
I think what John's saying is
you open up
what
a whole
are the
other
details
can of worms.
Of that? Yeah. And this has been the ongoing conversation throughout the conversation. Is like, what are the scales that we're talking about here? But if you don't want to go any deeper than that, which often the current mainstream media doesn't allow you to do, I think that number is actually true. But you have an issue that you want to
even if that number is true, thank you, Heath. Even if that number is true, it can be disingenuous, right? Because if you say like,
oh, you have to definitely do your own research as a person to know the complexity behind it. Yeah.
So,
but I do know that if the heat would go out here in the middle of winter, I'd be more likely to die if my air conditioning went out.
Here's the thing, though.
than if my air conditioning went out.
But we're not even talking about that. We're talking about climate change, right? So the statistic that he's bringing up is related to temperature. That's true. But it's not really talking about, like, is climate change good or bad? Or is the cost of mitigating climate change not worth the benefit?
Yeah, but I think now you're pretending like the phrase climate change is thoroughly developed, and it's not. And he's actually trying to give perspective on what we mean by climate change.
Yeah.
And if it's getting warmer, he's saying that's not a bad thing. If it were getting colder, then that would be a bad thing. And I have to agree with him on that. Like, the planet has never been greener in history, but recorded history that we know of. So what's the percentage of the atmosphere that's carbon dioxide?
What is it? It's like 370 parts per million, I think.
It's
375.
I think it's 0.04%.
See, but that's the same kind of. It's irrelevant, Heath. What the exact number is. That's irrelevant. What's relevant is.
I don't think it's irrelevant.
Well, see, the way you brought it up, the way you present it is like, it's so small, like it doesn't matter, right? That's your implication, right?
Yeah.
And it might matter like a lot. Like if there was a little bit of cyanide in this room, just a little bit of cyanide, right? Mm-hmm. It's just a tiny bit. It doesn't matter, right? But it can kill you.
Well, actually, that's funny because the Cialis that you have in the fridge. The
Celsius,
not
strength? Cialis. That's boner medication.
Yeah, dude. I'm like, what? This conversation. Like,
I got Cialis in my bag.
Yeah.
No.
Well, the Celsius apparently
energy drink you're talking about. Okay.
Apparently they
like,
get one.
I'm like, what?
Yeah, you want one?
Yeah. The vitamin B12 that's in it is actually comes from some sort of non-methylated that is. A cobalamin, what is it? Cyanide cobalamin. Mm-hmm. And so by itself, in that particular molecular structure, it's not cyanide. Mm-hmm. But we have no idea what it does when you get it inside your body. Does it break it? Does it break the molecule off and the cyanide come off of it? So you're right. I'm agreeing with you that minute things actually do matter. But the fact that we're talking about it means
Right.
that we're actually on the right track,
Yeah.
and that more speech is the solution to this problem.
Yeah. Yeah, I agree. I agree
but the
with you
fact of
there.
the matter is that plants make oxygen and they love carbon dioxide,
I mean,
and we make carbon
I
dioxide.
love oxygen.
So I really have a hard time believing that carbon dioxide is actually the evil that it's been betrayed as. And if America were to fix itself and just stop driving cars and stop making carbon dioxide altogether, what effect would it have on the output into the atmosphere? Don't the volcanoes have such an output of carbon dioxide and methane and other things into the atmosphere
But
that it makes
this
us
is-
like 0.01%
This is
of the issue?
this people have. There's an answer to the volcano. Actually, now that you bring it up, NASA. Like I have this conversation with my brother, my older brother, all the time.
What's his name?
Joe. And
Is he the one that has the gaming consoles? The gaming rigs that he goes through?
no, I think that's my other brother Chris. I might have told you about
Yeah, yeah.
when he was younger playing video games. But the point is, like, he's like this climate change, political policy is bullshit. And I was like, go look at the NASA website. NASA actually has a really good climate change, frequently asked questions kind of website.
But aren't you already
that
talking
addresses,
about
like, the
two different
volcanoes.
things, though? Because he's talking about the political agenda using climate,
Yes.
and you're
So-
talking about the reality of the science.
So when people say
And they
like,
aren't the same thing.
yeah, leaving the political stuff aside for a minute, which
Yeah.
I'm happy to talk about, but
No.
the
This is
scientific
interesting.
the scientific
Yeah.
like the consensus is like we have changed the environment, right? No doubt that, and I think where the science, in my opinion, my personal opinion, where it gets weaker is that predicting 100 years in the future what water levels will do in the ocean or how climate will affect people 100 years from now, I think is a very, very difficult thing to do. You can bring up, okay, volcanoes and ice cores did this and the Earth's orbit did that.
No, I
and-
agree with what you said
Yeah.
earlier about models.
Yeah.
Most of them are useless, and some of them are useful. Most of them
yeah.
are wrong, and some of them are useful.
all models are wrong. All models are wrong.
That's true. That's a better way to
Some
say
are
it.
useful.
Yeah.
So, like,
Can be useful in moderation.
Yeah. So
Yeah.
if let's
Do you know what he means by that, Zach?
All models are wrong, but some of them are useful.
Yeah, he's talking about like models of the universe, models
of physical reality.
Yeah,
If you
like
model something on your
simulations
computer,
of
even your CAD drawings, Heath, your CAD
of a
drawings
car hitting a wall and what it would do to the occupants inside.
Yeah.
Yeah.
They're all wrong because they don't necessarily.
They're not-
Until you take those people and put them in a car and run them into the wall, you actually really are not going to know what's going to happen.
Yeah, that seems accurate.
So you have uncertainty.
Yeah, so you
Even-
can put
even
dummies
in
in
the
a car,
prediction.
but it's still not the same thing as an actual person.
Like when you make a drawing of like a 1-inch cube, right? And the machinist makes a 1-inch cube, you can, the better you measure that cube, the more you can see that it's not really 1 inch.
Mm-hmm.
Your drawing, you can write 1 inch to 10 decimal places, and
This
can't
is
be
the
built.
conversation
Yeah.
around that I love the most with engineers, and I'm interested to
Yeah.
see what you think of this conversation.
Can we take a break though?
Oh, absolutely.
Yeah.
Yeah, let's take a break.
5 minute Okay.
Yeah.
Thanks. That's what I do.
Man. You guys got really technical on that last round.
Oh man, yeah.
What question was I going to ask you?
But I will say,
What were we talking about just before the...
Climate change.
climate change.
Yeah, we were
Gotta be more specific.
getting pretty deep into it.
I will say there seems to be a very great deal of like legacy when it comes to doing what you do, because from where I'm sitting, it sounded like you can spend the better part of your career working on the same thing. Like they try it and then something went wrong,
Yeah.
and you try it and they keep trying it.
Yeah.
Like you're taking on stuff that people were worked on before you, and they're still going to
Yeah.
be working on that same stuff after.
It's one of the nice things about working there. Definitely, there's a huge legacy and a history, a rich history. You know, like there are NASA historians who just archive the stories and make them accessible and stuff. And I appreciate it. I like working there and to be make some small contribution. That's a really good feeling towards some noble purpose.
Have you been to the data evaluation laboratory?
He's been looking stuff up while we've been talking.
Does not ring a bell. Where is that? Is that laboratory at Goddard?
It's at Goddard, but it's got the only surviving piece of equipment that can play the footage of the moon landing.
Yeah.
If they ever find it.
Yeah, somebody did that a few years ago. Like a private group had tapes, and they made, I think, the machinery to read those tapes back.
Well, I guess
Is this
If they find the tapes that they've magically lost.
in 2019, Sotheby's had a sale of 1,150 reels that were bought at a government surplus auction
Yeah.
in 1976, but they did not contain the footage that everybody's been looking for.
Okay.
Which I guess the only footage of the moon landing that they have is they filmed it off of the monitor. But there's this whole other set of tapes
the
that
original data, right?
it would actually be extremely good quality,
Yeah.
but they just I don't know how
That's
they
funny.
lost it.
So today we have archiving policies and procedures, and then 50 years ago, I'm not sure that they were thinking that far ahead. I mean,
Yeah.
I'm sure some people were, but they were like in such a mad rush to get to the moon.
Yeah.
To beat the Russians. That was priority one.
Did they land on the moon?
So I was thinking about this while we're on break, Keith. We were talking about a different topic. Like, do you think?
It's become a big conversation again lately.
So I had an interesting conversation with my dad about it. So my dad's 92 years old.
How old was he in '68?
In 68, he would have been 36. So I was talking with him just a year or two ago, and we were talking about NASA and something, and I forget what he said exactly was cast some doubt about whether we landed on the moon or not. And I like to debate and think critically about things. And I asked
not
him,
you.
Yeah. And
The only guy I know that likes to debate more than me is John.
I love a good debate, and it's my dad, so I want to talk to him, and I'm like, hey, whoa, back up. What did you just say? Like, you don't think 100% chance we landed on the moon? And he's like, well, no, we probably did. And I'm like, probably? What do you mean probably? Like, is it 50-50 we landed on the moon for real? Or is it like 70-30? He's like, oh, like 95% chance I'm sure we landed on the moon. I'm like, oh, okay, I understand. How about this? What are the chances that I'm your son? He's like, oh, 100%. Like, well, how do you know? We've never had like a DNA test or anything. Like, I could be somebody else's son. Happens all the time, right? He's like, no, I'm sure. I'm positive. I was there in the hospital. No doubt you're my son. I'm like, well, babies get switched at the hospitals accidentally, right? It doesn't happen now, but it used to happen that you would, nurses would switch the babies, or somebody would kidnap a baby or whatever they did. So it's not 100%
Yeah,
sure
unless
that
he
I'm the
saw
son.
you the entire time.
Yeah.
Yeah.
Like, and he just got, he got upset a little bit too. And
Well, that is kind of going for the heart of it. Like, you're calling his.
and I just want to have a conversation. I don't.
Yeah, but you're always really good at like.
What's the corner
like,
case? If you
let's
said,
peel off all of the sensitive stuff and let's go right to the.
I mean, I wasn't trying to hurt his feelings or anything or imply anything, but I'm like, if you haven't seen the thing with your own eyes, how do you know that thing really happened? You know, we were talking about some other event in world history, you and I, Heath, a minute ago, but like the reality is you have to accept someone else's assertion that this thing happened or didn't happen. And, you know, what is your test for?
Or just accept that you'll never know.
That's so difficult for people to have uncertainty. That's awful.
You know
for
what?
people.
You know what? I think that's not actually true. I think what people do is they adopt an ideology by accident, somebody else's truth, and I think the really difficult problem is for them to set that once they've adopted it is to change it or set it aside.
Yeah.
If they haven't made a decision on it already, I don't think that's a problem for most people. But the problem is that they get exposed to something by anybody, and now they've automatically adopted what they think is the truth to it.
Well,
I've been re-examining stuff that I believed, and like, when did I start believing that has been my magic to unraveling it. Some of the stuff that I believed when I was 50, I was like, I decided on that when I was 17. Maybe I should reconsider.
Yeah.
You know?
Yeah,
Just based on the fact that I'm not that guy anymore. I'm not a 17-year-old in any shape or form.
I think that's really common, though. Like,
Yeah, I
people
I agree with that.
people have a perception that, you know, based on something their second grade teacher told them, you know, like, you're dumb or you're smart. And,
Oh, yeah.
And then they carry that with them their whole lives.
Oh, yeah.
But
But it's kind of like vision, right? Like, can you 100% accurately tell me what's in your periphery without changing your focus? No. And the reason for that is because our brains are limited. And so we're constantly trying to pare down the information that's coming in and store it so that we can survive. Except nowadays, survival is about not being so quick to decision. It's not the other way around. We don't have tigers lurking around the corner at every moment. We're not living outside, and so now we have to stop pretending like our time scale isn't much longer at which we need to make these decisions at.
I'm all right with not knowing. I know we're never going to know who killed Kennedy. I know we're never going to know whether we went to the moon or not. I mean, I'm all right not knowing. I'm all right not knowing. The first thing I thought of when you talked about like the fancy lens on that, what is that called?
the spotting scope over
The
in the
spotting
corner.
scope. I thought about that lens that they sent to space, the Zeiss lens to record everything, and like Stanley Kubrick they made two of those lenses, and Stanley Kubrick got one because he made that movie Barry Lyndon right after, and he basically lit that movie by candlelight.
Yeah.
And
Very
it was
fast lens.
Yeah, and that lens was like the only thing he could accomplish that with was that moon landing lens, which lends itself to the theory that Stanley Kubrick filmed the moon landing on a soundstage.
So I started thinking more about, like, why do people believe what they believe? And, you know, in criminal law, like, to prove to a jury that, you know, so-and-so is guilty of this crime, you have to have beyond a reasonable doubt of evidence. And most people know also that in a civil case, you have to have a preponderance of evidence, right? More likely than not.
Okay.
To prove. So a different standard of evidence, lower standard for civil cases than criminal.
Yeah, because of the Christian belief that people should go free if you can't prove. It's better to have 10 guilty people
More
go
guilty,
free
yeah.
than for one innocent person to be incarcerated.
Right. So
I never heard that.
That's actually what
our value as in the legal system.
Well,
that's the system we have.
That's the system that's in place. Absolutely,
and
it's a very Christian.
But those
belief.
those two levels of standard of evidence, there are 2 out of 7 in the legal system. Like you can.
Why do you know this?
Because I want to know, like, why do you believe X, and do you?
Yeah, but why do you know there's 7 different?
Because I looked it up. on Wikipedia.
Okay.
And I'm like, I'm thinking like,
Can
why-
you
wh-
expand on that? Because that's very interesting to me that you
Here's-
wanted to know that.
Here's yeah, no, for sure. And if you're talking about like, did we land on the moon or not, right? Can I prove to you 100% that we landed on the moon? I could take you to the moon and show you the Apollo, the stages that we left behind. And you could say, well, no, you planted these a year ago. We didn't go 50 years ago. Like, I can't take you back in time and we can't witness those things, right?
Yeah.
So there's enough evidence of...
Not unless we go through a wormhole and catch the light.
Yeah, not yet.
So go
Can't
back
go back in time yet.
Yeah.
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 Well, I was just thinking going out in outer space and reflected light,
Oh, to
watch
catch the
light coming
the
off the
light wave.
moon
Right.
at the actual time that it happened.
So there's enough in my mind. Like, I believe we landed on the moon in the 60s, and that there's enough physical evidence. And if you think about the situation, the political situation with the Russians back then, the Russians had physical evidence that we landed on the moon back then. They saw the orbit of our trajectory of our spacecraft on their radars. They intercepted our radio communications from that distance and direction. So the Russians, if there was a conspiracy that made Stanley Kubrick film on a soundstage, the Russians would have had to been in on it and helping keep the secret, right?
Right.
So in my mind, and we can actually, we've seen...
Not unless they wanted to stop the whole spending of money on the race.
I mean...
I don't know what
so-
their reasons would be, but maybe they had a reason to not.
That it doesn't...
The only reason I'm saying this, let me give the only reason because I've been going over a lot of the conspiracy theories lately that turned out very recently, after COVID.
Yeah.
Everybody's just kind of like reevaluating everything they thought, like, oh, that's just a conspiracy theory.
Yeah.
And, one of the biggest ones is like diet and all sorts of different stuff to do with that and what's going on with the medical industry. And so I've just been turning over all these stones and reevaluating all of them. And you're right. We really don't even hit the moon. Why don't we have pictures from down here of the shit on the moon?
You can't. It's like saying, why can't your eye image the surface of the sun? You just simply can't. It's physically impossible. But you can send a spacecraft to orbit the moon.
Isn't it on the light side of the moon? They're
Yeah.
landing?
Yeah.
Aren't we looking at it all of the time? So why can't we?
Why can't you see it from Earth?
Yeah.
It's too far away. It's like saying, why can't we see mountains on the surface of Pluto?
Well, we can
From Earth.
see.
We
but,
can't.
But we have telescopes that see way out
You
into the
can't-
solar system.
Yeah, but you can't. The way light works, you cannot just infinitely magnify an image to get more and more detail. You need an infinitely large telescope.
But we couldn't get one that's powerful enough.
Not from Earth, no.
No?
And also the Earth's atmosphere blurs the image.
What if you were to do a
A large interferometer,
no, like what we do with radio towers?
those are radio,
There's another name for them.
like the Goldstone array of
Array.
interferometric telescopes. Yeah,
Like what Charlie Sheen does in that one movie Arrival.
Yes.
With all of the
That's a
dish
yes.
networks.
That's
So why can't we do that with a bunch of telescopes
because
and then just put all the images together?
because the Earth's atmosphere blurs it more than those things can correct for. The motion, the atmosphere acts like a lens that blurs everything.
I got a question for you. What if we were to put those all on all of the new Starlinks that are out there, looking out into outer space?
So you, in theory, you could,
Wouldn't that be cool?
You could build a telescope with enough resolution to image things on the moon from the Earth's orbit above the atmosphere. Yes, if you spent enough money, you could build something that could image things on the moon from the Earth. I believe, yeah, that can be done, but it would take a lot of money.
I was just thinking a
easier-
low-resolution
it's easier-
camera on all of the Starlink satellites, which there's thousands of them. And so you're combining
There's an-
images that
there's
have
an-
no
there's another tech-
distortion from the atmosphere.
There's another technical problem with that, though, is that not only do you need to have the individual cameras separated by, like, I'm just picking a number out of thin air, but like you would need a telescope maybe a kilometer in diameter.
Okay.
So you could have two smaller telescopes a kilometer apart imaging the moon, say, with enough resolution. But then you have to control the distance between those two cameras very precisely. And you couldn't do that with satellites. It can be done. It can be done, but not with the Starlink platform. There's a project called LISA, LISA. I forget what the acronym stands for, but it's basically what you're talking about. It's an interferometer. I think it's 3 satellites. So if a gravity wave came through and disturbed the positions of those satellites, where, like, you can see the wave coming through because it hits the first satellite, that changes the spacing to the second and third. And anyway, it'd be like the wind coming. You can see it hits the first sailboat, and then it hits the second sailboat, and then it hits the third sailboat. So you know what direction that wind is going and how fast it's going, or an analogy. So to do that, to have 3 satellites with enough resolution to detect a gravity wave now, you have to know the positions of those satellites to, like, within an atomic diameter or something ridiculously small. That's how well you have to know the position and control that position. So in the Earth's
know
orbit,
or also control, or just know?
both. Or I think you could do it with just knowledge, but
Because I don't see how you'd be able to control it.
so bottom line, Heath, is, you know, to build a satellite to image the surface of the moon would cost, I don't know, $1 trillion. It would be cheaper to send you to the moon, and you can look for yourself. But then, you know, nobody would believe you because you'd be in on the conspiracy, right? You could be lying. But my point is just that, like, what is the standard of evidence for you to believe that there's a God versus for you to believe that your neighbor is, you know, whatever he is, versus, you know, what is this piece of fruit that I'm eating in front of me? Is this a plum? Do you know for sure it's a plum? Like, you know,
Right.
you know, probably, you know, the stakes there are pretty low. It doesn't matter if it's a plum or an apricot or whatever that is. And, but then there's a whole nother layer to this onion, Heath. Like, why would somebody question whether or not we went to the moon? What is even the point of asking that question? It's like asking, like, you know, did Napoleon win or lose at the Battle of Waterloo? Well, I think he won, actually. Can you prove that he did or didn't? You can't. You can read some texts about it, but what's the point? Like, why would I even question whether or not Napoleon won or lost at Waterloo?
Well, I think the reason people are going back and asking why is because everything that we've ever been told by our government has been turned upside down and go, have they been telling us the truth? And I think that one thing is for sure is that our government shouldn't be allowed to keep any secrets from us. Any. And I mean any.
What about the secret to how to build a nuclear bomb in
Nope.
specific detail?
Nope.
You should be able to know that?
Yep.
Why?
Because I paid for it. They work for me, not the other way around. They work for all of us. We should all have a right to all of the information, all of the time, and all of the truth all of the time. Otherwise, how do we know it's the truth?
Well, who do
So
you mean,
the reason
who
we're-
do you mean by we?
The
Who do you
point
mean-
I'm trying to
which
make
we?
is to answer your question.
Yeah.
The way that you know the truth is if the truth is all that's ever being.
Okay, but let's
So
say
there's no secrets.
let's say
there's no secrets allowed.
yes.
So this is the truth.
So Heath, you can't.
The reason why we fight amongst each other is because we don't trust each other, because we don't share everything with each other. It isn't the other way around. We don't keep secrets to keep ourselves safe from each other. We're keeping secrets, and it's costing us to not be safe from each other. It's the opposite of what they believe it to be true. And I think it's propaganda that makes us believe that that keeping secrets keeps us safe. It's actually the opposite. Not keeping secrets is what keeps us safe.
So let's back up a minute, back to the moon landing conspiracy. Sure. So let's say somebody gave you access to all the information about the moon landing,
or just JFK. Yeah.
Well, let's be specific.
Like, I mean, one's on the planet, one's not.
About the moon landing.
Okay.
Let's say you had access. You had a special card that gave you access to any database, any information you wanted, and you spent the next 10 years exhaustively researching the question. Do you think you would have an answer for sure?
What do you mean?
Could you tell somebody, yeah, now after 10 years, I'm 100% sure we landed on the moon? If you had access to all information that exists today in the government archives or wherever you want to go to look for information.
Well, I think you're actually missing the mark on the correct question. I think just like Hitchhiker's Guide to the Galaxy, the most important thing is are you asking the right damn question?
Yeah.
And I don't think you're asking the right question.
Well, I think people hurt their case. If you have a complaint,
do you know what truth is?
Yeah, it's what I say it is. No, I'm joking, but
no, it's a hard question. People don't realize that it's all from perspective.
Yeah,
like you can't say that this is the truth because it depends on what you're talking about. First of all, like do leeches actually help patients from doctors?
Mm-hmm.
Well, it depends on what you're talking about because there are medical reasons to use them.
Mm-hmm.
But for the most part, what they were ever used for, the answer to that is no. Bleeding people is actually the opposite. Yeah. Like that's how they killed the first president by accident, was bleeding him to death.
Oops.
But those people were the professionals back then, the oracles that were trusted with the knowledge to doctor people.
Yeah.
And so when you have dissemination of information that relies on oracles, you end up with that kind of flawed thinking all of the time. So stop keeping secrets. And in that day and age, when every one of us has one of these, and you put out the information and it's the truth, then what do we have to fear other than fear itself?
I was thinking before that your theory about information and secrets sounded kind of communistic. And now that you quote Roosevelt, now I'm sure of it. No, but
is that Roosevelt?
That was Roosevelt. We have nothing to fear but fear itself.
Yeah?
Yeah.
Why is that communism?
He was a socialist, not communism.
Doesn't make everything that he said
no,
communistic.
I was making a joke, but how about this, Heath? Specifically, the Air Force is designing the next generation fighter, the next generation bomber. They're upgrading intercontinental ballistic missiles, and they have all this information. Should that be secret on the design? The design details of those weapons should be open to everyone?
Yes.
Why?
If you don't want people to know about it, why? What is your incentive?
Yeah. Well,
you want to have a bat to beat them with that you don't want them to have? Then don't make one.
Well, I think you're denying human nature then.
No, I'm saying I'm drawing it right out into the open. Keeping secrets is what makes people distrust each other.
Yeah, I would say that's true. But
if you get rid of distrust, do you really have more?
You're saying don't keep any secrets.
Yeah, I'm not saying that this isn't a controversial conversation. Yeah. I'm not saying that at all. This is definitely going to I'm not going to have hardly anybody that agrees with me on this.
Right.
But I've thought about it a lot, and I don't see any reason why a government that uses our tax dollars should be allowed to keep secrets from us, especially when they misuse them and abuse them to the level that they always have. Like, for instance, the food pyramid, which is a complete and utter lie that has killed and hurt so many people here in America.
So what do you
The
think?
majority of your diet should be from grains and starches? Really?
What do you think?
I don't eat them at all anymore.
What do you think the best form of government would be?
The best form of government that has ever been invented is the one that you and I live in right now. So I can't answer that.
But you have complaints about
Yes.
the way the government works,
Yes,
right?
and I'm allowed to complain because our government is so superior to other governments that don't allow that.
Yeah. I'm not saying you
Yeah.
should or shouldn't
No.
complain, but I'm saying you have
I know
complaints.
you weren't. I know you weren't. Yeah.
You have complaints about what you think is the best form of government. So there's probably things that you would do differently if you made the rules.
I don't want to be the one that makes the rules. I want the truth to be for everybody to decide together. I don't want a group of politicians that I can't trust because they keep secrets from us.
Mm-hmm.
Like this guy I was watching on TikTok, who's a congressman, said, "This data that I learned about TikTok is why I believe we should ban it.
Mm-hmm.
But I can't share it with you because it was in a skiff." What data could they possibly have on TikTok that would be dangerous for the United States public to understand about what's going on with TikTok? It literally makes no sense to keep these secrets from the public unless they want control from those secrets or perceived secrets even. Like maybe if it was put out in the open, it's actually not true.
If it's put out in the open, it's not a secret anymore, right? I mean,
Maybe it's not true.
Yeah.
Maybe it's only true because it's a secret, and the source that it's coming from is what gives it its authenticity.
Yeah. So that's,
Oh, this is coming from the CIA, so it must be true. I'm sorry, I don't believe that at all anymore. I don't think that that organization has any of our best interests in mind. In fact, I don't even think I think that's a communist organization operating here in America. Their own little oligarchy of control, you know. And the reason I think that is because everything that they do is in secret, which is how tyrants work.
yeah, I see what you're saying. I mean,
They're also not actually a form or an official part of the founding fathers' government. Their power is derived from our Congress. And so a lot of the things that they have done, they've actually never got permission to do. I have to agree with Vivek on this. Just no more CIA. Gone.
Yeah, I think he was talking about the FBI.
He was talking
Right.
about a lot of them,
All of them?
including the teachers,
Department of Education.
Department of Education, especially.
And also the
Because
Nuclear Regulatory Agency,
yeah,
too.
absolutely, the regulatory capture in this country is because of all the goddamn secrets. And I don't see any way to step up to this slowly. Like everybody's at work and other places are always trying to say, well, we need to sneak up on the correct thing to do. And I just don't see how you're going to decide that these secrets should be secrets and these secrets should not be secrets. Should we have secrets is really the question. And my thinking is that no, it just devolves into corruption whenever you have secrets, because human nature, like you said, human nature. What do people do with secrets? They use them to their advantage.
Well, yeah, it's human nature to want. There's like this duality of we want to have more than everyone else around us, but we also want to help people. And that's something to balance. Each person has to decide how they balance that. You know, if you just want more and more for yourself, you're quote selfish, and if you just want to give it away and help everyone else, then that's, you know, there's different labels for that. But so we balance that all the time as people, and then I think the government that's evolved that we live with today has evolved from, I think people are doing the best they can, like individually, and then in the government. Like I'll speak for people who work at NASA. We're all like super dedicated. We love the mission that we're working on. It's like the best place to work in the federal government every year, and I'm extrapolating from that to other government agencies, who, like when you're talking about the CIA or the FBI or the DOE, in general, people are good and they want to do good for themselves and for people around them, right? There are evil people, I think, who do bad things, right? But I think most people are good, and the general trend of humanity is getting better, right? And there are pockets where, sure, there's evil people and there's evil organizations, and I think, but I'm optimistic. I think, personally, I do believe like in good and evil, and I think that, generally good wins. Sometimes evil wins, personally and, regionally and on continent scales. Sometimes evil wins, yeah. But generally, over time, it's getting better. A lot of because of information that you're talking about, secrets versus non-secrets.
Yeah.
More information, I think, in general, is good.
Like books, like the printing press.
Like your handheld computer and free speech and
let's
debate.
think about what the church tried to do with the printing press when it first came out. They wanted they wanted to maintain control over it. They wanted the priests to hand out the information to they didn't want people to read the Bible for themselves. Mm-hmm. They wanted them to go to the priest for it, and I don't know exactly what the history is on it. I can't say it verbatim, but there was a definite time where they didn't want the printing press to be disseminated out, and so every time. Yeah, I think I came to this conclusion for myself after reading The Sovereign Individual, where it basically said technology is what allows people to be individually sovereign. Like, I agree with you. If that guy wants to have a Humvee or something like that gets 14 miles to the gallon, I don't believe it's actually fuel made from fossils anymore anyway, so... The fact that nobody can prove that we're ever going to run out of these fuels anyway. The sun is the source of all power. It's even if it was fossil fuels, the sun is the source of that. Long-term wise,
sure,
right? Grew the plants that grew the animals that ate the plants that died and created the oil and natural gas. So, I mean, I don't think there's anything that we can look at that doesn't come from solar energy.
Yeah, but it's hard for
including the volcanic activity that has things growing in the depths of the sea that's in a complete darkness.
But we're focused on what's going to happen in our lifetime and for our kids, right? So we generally focus on the next 5 years, 10, 50 years, right? That's what we focus on.
That's reasonable to say, yeah.
I'm super optimistic. If you think about where we were 50 years ago, and the changes that have happened in the last 50 years, I think we'll change more in the next 50 years. In some ways better, in some ways worse. But like I said earlier, like I'm optimistic about people are generally good. I think technology generally helps. So this is why I would like to live for a long time. Because just in my lifetime, things have changed a lot. Like I used to remember playing games like that were not on the computer, like board games, and I'm not talking about Monopoly. I'm talking about other detailed, complex
like Risk
games, like way beyond Risk, like Air War, or War in the Pacific.
Well, maybe we are
Squad Leader.
Maybe we are in one of those games for.
We're in that simulation for somebody else. Yeah.
For other humans on the planet,
But, I remember growing up.
I mean, The Sims
was really different than it is now. And, so I can remember the past 50 years, there's been a lot of change. And I think the next 50 years and the next 50 years will be even like unimaginable change, generally for the good. So I'm interested in staying healthy and working out and eating better and all those things people do, and more other things like, longevity kind of things.
Have you looked into stem cells at all?
Sure. Yeah.
Have you been considering going
So
to get stem cells?
I looked at it and I thought at the time, so I'm starting with a limited budget in terms of money and time and energy, and I think, and it's not clear to me that they would help achieve my goals, right? So there's, aside from stem cells, you could name like 6 other therapies and treatments and vitamins and molecules and supplements and behaviors. There's a lot out there, right?
Aren't they mostly used for repair? So if you were to go and get like stem cell IV once a year, wouldn't it repair your circulatory system, which
I think it would.
Helps you with longevity at the base level?
Yeah, I think it could help. Yeah. But the point is, it costs a lot of money, and I'm not sure what the benefit is. Right? So I'm not saying it's a bad thing.
No, I'm asking you
work,
because I'm researching it now myself.
Okay. So this is a lot of my friends are
I don't
looking
have
at
answers
this. I
either.
remember I met a buddy. He worked at the Mission Design Lab, actually. He was a visiting engineer from JPL. We were talking at a bar after work one day, and I noticed he was drinking a Diet Coke. And I was having a beer of some kind, and I'm like, I'm just curious, do you not drink alcohol for religious reasons or something, or what's your story? And he's like, no, I just, I want to live for a long time. And I'm like, what do you mean? He's like, oh, I want to live to be like 200, 300 years old, potentially. I was like, wow, that sounds crazy. Tell me more. And that was his approach. One of his approaches is he's just simply not drinking alcohol.
How long ago was that?
That was about 10, 12 years ago now.
Okay. Have you ever seen a skinny person drinking a Diet Coke?
Yeah.
Yeah?
Yeah.
Yeah.
I haven't.
Well, I mean, once you start talking about a person, though, so many people are so different. Here's another thing. This is related.
Finish your other story before you go on a tangent. I'm sorry for distracting you.
No, it's okay. And so he initially got me thinking about it. Like, do I want to live for a long time? Sure. Like most
how long though?
say,
A long time
how
for
long
humans?
do I want to live? Yeah, I would love to
or
live
a long
to be,
time for the age of the planet.
Just to be realistic, I would say I would be happy if I could live to be 150. So 100. Almost 100 more years, and I would say like in that time, like I'll see a lot of really cool stuff and be able to participate in some really cool things.
Mm-hmm.
That's what my goal would be.
Mm-hmm.
And it could be completely silly, but
are you going to go Neuralink?
Would I go Neuralink? Like,
so you could maybe help you accomplish that?
I don't think so. I mean,
you're 110 years old.
Yeah.
Would you get a Neuralink so you could live longer?
Sure.
Yeah.
If I thought, see, you gotta balance the pros and the cons.
Yeah. That's why I said you're 110.
Yeah.
You're already freaking old.
Yeah. And the Neuralink technology is 50 years old. It's probably well developed. Sure.
Yeah.
If I saw the benefit. So like now, all I'm doing now is exercising and trying to eat better, and I take resveratrol. Sorry, resveratrol from grape skins or
I know what it's
red
from.
wine. Okay,
yep.
And then I also started just taking NMN molecule, the precursor to I think NAD plus for more energy.
Do you get NAD infusions?
No.
How about NAD directly itself?
Here's the other thing, though. No,
did you feel anything from the
I've only started it like a week ago.
Okay, well let me know because I'm interested. Definitely. Okay. Do you know what we're talking about?
NMN molecule.
Is it NMN? Yeah.
NMN.
Yeah, it's a precursor your body converts into NAD, which is some
fancy.
kind of
you can say it fast. I can't.
Some kind of energy. Yeah.
And so you started taking it a week ago.
About a week ago, yeah.
And it takes a little bit of time to.
I have no idea.
Yeah.
I'm copying David Sinclair's protocol.
I know who he is.
David
tell Zach.
Sinclair, he's a geneticist, biologist studying longevity. And he's written some books. I forget his book, his big book.
So you think he's credible?
I think he's credible. It's not my area.
What about listening to his videos, his podcasts and stuff? Did you have anything specific that made you feel that way?
I think, his credentials from authority and the fact that from reading his book, there was also some good arguments in there.
Do you know the name of it?
I struggle to remember very much. David Sinclair's something about longevity. And then also the other person I've been studying is Peter Diamandis. His approach, he's in a similar
do you follow
longevity.
Andrew Huberman?
Not Huberman, no. So but Diamandis had this approach where, like, first you don't die of something stupid like an accident or heart disease or cancer if you can help it. So I had a full body scan, a full body CT scan to rule out any asymptomatic large scale cancers. Right at that time, a few years ago, nothing showed up. And
where'd you get it done?
Just some clinic in Rockville. And
do they do them over here at the Annapolis Imaging Center?
Probably.
Yeah.
The reason I decided to do it was the benefit. Like, if the benefit is like something like 5 or 6% of people who do it.
Hey, did you get that heart scan that we talked about?
I did, actually. Yeah, I did.
What was your score?
I did. It's low 80s. And here's the nice thing is, I had that.
What's the scale?
The calcium score. I think below 50 is really good or something. And 50 to 100 is some extra risk, and I think the number can get very high in the hundreds. My point is that full body scan I took 5 years ago also measured my calcium score, and it was in the low 80s, and it's in the low 80s now.
So it hasn't moved.
It hasn't.
That's good news.
And I think, I was pretty happy. Like, I was hoping it would go down, but I don't think it can go down. I think it only goes up. Once that hard calcium is in your arteries, it doesn't get fixed.
From the transition that I made from 2019 to what I totally disagree with that. I don't know how to control it, but I have reversed things that I thought were permanent in my life.
Like what? Well, specifically, you didn't have your calcium score measured back then and now, did you?
No, and I'm not sure that I understand the score, because I've heard people talk about it in the thousands, and I've heard.
I think it probably can be. Yeah.
I think it's a difference in technician reading the results, unfortunately, and so I need to do some research of what the calibration scale is supposed to be, because I was told it was 0 through 5, and mine was a 0. 5 being the worst, 0 being the best.
Yeah,
it doesn't even
group the numbers differently.
The number that I was given doesn't even correlate to what you're telling me.
Yeah, it's a different test. It sounds.
It could be just the difference between you went to this facility and I went to LabQuest, and you went, and they just they look at the results differently.
They need a guy like you talking and making sure everybody's speaking the same language.
Yeah.
Well, this is why you don't keep secrets, right? So that you can say, "Hey, you guys aren't talking about the same thing."
Full circle, right?
You guys aren't talking about the same thing. How do you know? Because there's no secrets here. I'm looking at both. And they don't correlate.
Yeah, you have to be clear about what you're talking about, and most people are not clear, which is why we get upset.
I don't know that that's true.
Here's what I believe, Heath. I think all upsets are the result of unmet expectations. Do you remember? Did we have this conversation?
I think I'm the one who actually said this phrase to you the first time, and I'm really happy that you're kind of remembering. I think this is how it goes. Unexpressed needs are future resentments.
That's almost the same. Yeah.
Yeah. Like if you're in a relationship, like you and I, as we build this podcast, if I hate the way that you're doing this, or in reverse, if I continually question everything about the way that you set things up and you don't say anything back to me, eventually you'll resent me for constantly micromanaging you.
Yep.
So it's better off that you would go, shut the fuck up, I'm going to put things where I want them, and us to have it out.
Yeah, just come to an agreement.
And also...
Well, yeah, but I wouldn't say it like that. I wouldn't be like, shut the fuck up.
No, I wasn't
You know
trying
what
to put words in your mouth.
But I'm saying there's
like,
a way, there's a better way for me to handle that situation.
Well, you can't say nothing, is
Right,
my point.
but I got to say something.
Yeah, you got to say something.
But I could say a lot of I could go
yeah,
a bunch of different ways.
Actually, he was giving me shit because I questioned where he put the arms. That's why he was giving me shit when I went to move my arm. Yeah. And he was right. I don't need to be I don't even need to be involved in that decision.
Yeah.
And I don't know if you've read this book, but I know that I mentioned it to you. And it, Never Split the Difference has been like a game changer in my life.
I haven't read it.
Because Never Split the Difference is exactly what it sounds like, and it sounds like an unreasonable way to be. Like if you're in an argument and you won't negotiate, but it doesn't mean that you don't give in even though you know the other person is wrong or you believe them to be wrong. It's like if you were arguing with your spouse, you should not meet them halfway. You should go with one or the other's decision, because otherwise you walk away from that decision, both of you feeling like the other one fucking owes you something.
I could see that, yeah.
Right? And so now you have this future...
Resentment, breeding.
I have this package over here, this box, where I keep all the things that, how many times she owes me something. And it just builds up over time.
The emotional bank account.
Right. And now you're basically saying, it's future resentment.
Yeah. When
if you clearly gave in and it was stated as a part of the argument, I'm going to give you your way. I 100% do not like this, but we have to move forward. Mm-hmm. Everybody knows where everybody stands.
Yeah.
No resentments come from that.
Yeah.
I mean, what could happen later on is she or he could say, well, you should have taken a harder stance on it if you really didn't believe me, and this is how it turned out. That's a fair statement. Maybe you should have taken a harder stance. But at least now you're arguing about the truth.
Yeah.
And not some sort of bullshit, let's compromise.
Well, Zach, you said a minute ago, if we take what we're talking about and we zoom up to a bigger level, the bigger picture, you said you wouldn't bring it up that way, right?
Right.
You would bring it up a more effective way.
Yes, correct.
And this is exactly where my life philosophy is going. Is what's most effective? What's not necessarily the best way, but whatever my goal is, what's the most effective way to get there? And the communication and how you talk to somebody is obviously a big part of it. The other thing I really like is when you remove morality from the question of, should we do this or should we do that? This is evil, that's good. Of course, we want to do the good thing, but what's my point here is like with if you did something and I judged you as bad, you did a bad thing, right? Yep. That really gets in the way of let's say we're business partners and you did something stupid.
Well, why do you think it gets in the way? Isn't it the whole point to operate your life morally?
No, if I did something bad that got in the way of the business, then what?
You're Heath. Wait, you're saying, don't we want to operate morally?
Isn't morally the whole way you decide on what's good and bad?
Yeah, but what I'm saying,
isn't moral at the base of all the real decisions?
It is, but what I'm saying is
anything else. So if you you said at the beginning of this, you need to remove morality from the conversation, and I'm like, how do you do that?
It can be more effective. What I'm saying is, let's in the business partner context, okay, if I say you're a goddamn idiot, you just cost us $1,000 of unnecessary expense, you're just like blah blah, and I hammer you. I may be completely 100% right on the facts, but then I'm damaging our relationship with my language, right?
Yeah.
So that kind of.
Did you know that when you make somebody upset, you lower their IQ? So now you've decided to argue with someone who's dumber than you could have if you didn't make them upset?
I see what you mean.
Yeah.
That does
So
make
it's
sense.
really against your own personal interest to poke somebody and make them upset at the beginning. I'm agreeing with you.
Yeah.
Yeah. It's
I see.
it's counterproductive to your goal.
To cut somebody down like that.
Yeah.
Yeah.
And I didn't come up with that. That's from Chris Voss from that book, Never Split the Difference. It's like
that
you
makes
don't want to make people upset in the beginning of a negotiation. That just makes them dumber.
Well, let me get back on track. With,
I love it when you take a breath and go,
Yeah.
what does that mean?
I'm so contrarian. I immediately try to think of an example to prove you wrong.
I know that about you. We've been friends a long time. I know that about you.
I just sold a car. I've been trying to sell this car for over 3 years.
You got rid of the
Corvette.
The Corvette?
The Corvette is gone.
Oh, man.
38 months it took me to sell.
What kind of Corvette
No,
was
dude.
it?
It was,
No, dude. Like 5 years.
dude. I
Took you 4 years to decide.
From the date I listed, the first advertisement, I've probably been talking about it for 10 years.
Yeah,
But
fair.
I listed the ad 38 months ago, and I finally sold it last weekend. And I'll be
Do you
honest,
feel lighter?
lighter?
Yeah.
Well, yes and no. Like, obviously, I don't have to worry about it. I made a deal with my wife. I would sell the car because we got another car, and it felt good to finally resolve that and keep my word about selling the car. But I really like the car. It was a really fun car to drive, and so I feel bad about that. So in negotiating with the buyer, I thought to myself, I could just piss this guy off right away, and I won't be able to sell the car. I could keep the car.
Yeah.
But I didn't do that. But the thought occurred to me to piss him off in the negotiation. Problem was, there was no negotiation. It was the easiest sale I've ever done. The guy, he was going to come down here today. In fact, he's like, "Can I come to Annapolis the 24th?" And I said, "No. If
How old was he?
he was our age, mid-50s probably.
He just wanted that year.
He wanted that car. He had a 75 in the past. He liked Corvettes.
Oh, was it 75?
Mine was a 94.
94.
So a C4 generation convertible. I listed
Black.
it black top, black interior. I listed it for $7,500, and he wanted to come down here today. This was 2 weeks ago. We're having this conversation. I said, "Nah, then the 24th, I want to go to Corvettes at Carlisle and try to sell the car there. So if you don't show up, I'll miss that opportunity." So he said, "Well, I can't come this weekend," which was a week ago, "because I'm watching my daughter's dog." And I said, "Well, why don't I come up there?" So I drive up there to Philly last weekend. Halfway up there, it starts raining, and water's leaking into the interior. And
He's driving the car he's selling.
I'm driving the car I'm selling up to Philly for this guy to look at it, and we, he wanted to pay me cash, and I'm like, I don't want to walk around with $7,500 in cash in Philly for any length of time. And so I'm like, can your bank wire the money to my bank on Saturday? No, they can't do that. So we went to his bank. First of all, I rolled up there. We talked for a few minutes, and he's like, "Okay, let's go to the bank. Let's do the deal." He never even sat in the car. He never drove it because it was still raining a little bit.
You drove him the product up there. He
knew it could make the trip, but
Yeah.
there were things wrong with the car, and I
Yeah,
think
but you drove it to him. He knew it worked.
Definitely could make the trip.
I would need to drive it, man.
Yeah, I'm like, well, he's a little shorter than me, so he'll definitely fit,
Yeah.
But like, I don't know. That was, he's a nice guy, and I didn't want to take advantage of him. I was upfront with like all the defects, and I think he'll like the car. It's a good car and all this stuff. But just your point about negotiating and pissing somebody off, I thought like I could easily just like
That's a badass car.
Thank you. Yeah,
I like those
really like it.
90s, like, I saw a 90s Porsche in, like, driving around Annapolis. It was so badass.
Yeah.
I saw a guy on the internet with a new Corvette,
Mm-hmm.
no tags on it at all. And he's got a one of those 360 cameras on the
Yeah.
top.
Yeah.
And then the second a cop sees him and turns on the lights, he just takes off. And the whole video is him just running from the cops.
Oh, wow.
And it's like a big mystery who he is because he doesn't have any tags on
You
the car.
saw the car in person?
I saw it on
On YouTube or something?
on yeah.
Yeah, I've seen that on YouTube too.
It's pretty bad.
And that's why I was asking you if you saw it in person, because it was like, that's around here?
I would follow him.
Yeah.
I'd slip an air tag on his car and be like, I know who you are.
That's funny.
Well, he's not parking. He that's Batman. He's parking in the cave somewhere.
That is a total Batman move.
Yeah,
like,
you know, I mean, he's not parking that on the street.
yeah.
He's got
he's
an
got a
extra
garage,
gas tank
yeah.
put in it
Yeah.
so that he
Catch
can
me
go.
if you can.
He's got an extra gas tank in it so that he can go further than anybody can expect. Otherwise, they just drive him until he run out of gas. They just keep
Yeah,
following
or a
him.
chopper, whatever the police
Yeah.
procedure
Right.
is.
Chopper.
You know,
Before you said you were the engineering you do now is like your hobby in your garage working with your
Yeah.
cars. What kind of cool shit do you do?
tell him about your new car.
My newest car is an 87 Porsche 924S,
Oh,
and it's been lightweighted for racing. It was raced in the Porsche Cup Series. And
I haven't even seen this one yet.
it's nice. It's guards red. It's been lightweighted, so the door cards are removed. The carpet and soundproofing is removed. It's got racing bucket seats.
What are they called?
They're racing
Recaro,
seats.
right?
They're not Recaro. They're like Force 5 or Force.
They're like Recaro,
G-Force.
though.
They're
Yeah.
G-Force seats.
G-Force.
Yeah, deep buckets. It's hard to get in and out. And so I bought it to do autocrossing and maybe take it up to Summit Point and do high performance driver education, just to have fun, just have a car to drive. Because my other car that I'm working on is like a long term.
What's your other car?
20-year project. It's a Ferrari, a 1983 Ferrari 512 BBI.
1983, you said?
83. So you know the Ferrari Testarossa?
Yep.
This is the car right before that is what became the Testarossa. So same flat 12 engine in back.
That's badass.
It's the Magnum
It's-
PI Ferrari, right?
No, he actually had a 308 and a 328. So that's an 8-cylinder mid-engine. This is the step above that. Their flagship car at the time was a 12-cylinder flat 12 engine, mid-engine, and the 5-speed gearbox is underneath.
Tell them what a flat is.
Flat is so like you have a V8 engine that's like a
Yep.
90-degree V8. This is a V12, but a 180-degree V12. And so a lot of 180-degree engines are boxers, like Subarus have like I think a 4 or 6, or Porsches have boxers where the pistons
The
go
Boxster
in
is
and
a
out.
is a flat, isn't it?
I think it is.
Yeah.
But the Boxster Porsche, I don't know Porsches that well. I'm not sure that it's a boxer engine. It can be flat 180-degree V12, and if the pistons move together, both left and then both right, that's what I have. So it's a V12, but not a boxer. Okay, and it's a small point, but so I got it like off Craigslist. I saw two.
20 years ago.
No, it's a 20-year project in the sense that I just got it 4 years ago, and it's
Okay.
going to take me 20 years because it's all in pieces.
Gotcha.
It's in a million pieces,
Yeah.
and I spent like the last 2 years working on the engine only, an engine and the gearbox. I took apart, not completely, but enough to know.
Now you got more space. You can do more Ferrari project.
That's cool, man.
Yeah, I'm really enjoying it. Like I took a break. Like I haven't worked on it in like a year because I did like a lot.
Yep.
Got the engine to fire properly, and I've been working on other projects now, but this one's coming back. So I got like the engine's out of the car, transmission's out of the car. I need to do like the suspension. The interior is gutted. It's a shell. basically.
The thing that makes it the 20-year project is he's trying to restore it to original. He's not trying to upgrade it.
Right.
And so
So it's like
that makes it harder.
it's all in boxes. Yeah. So like what I'm doing next is the suspension, right? So these steel, they're control arms, shocks and bushings.
20 years though, dude. A replicator might be out by then.
Just print one up. But
So you know.
so it's basically an investment car. Like I'm investing sweat equity. I bought it for half of what they would go for, and I intend to sell it for 8 times that, whatever, in the future.
Oh, man, after 20 years though, that's going to be like.
Yeah, it's so I looked on like on the forums, like who else owns this car?
Yeah.
And there's a guy like 5 miles from here who owns like the exact same car, and it's in like 100-point, concourse judged level. It's like done, finished, beautiful, perfect. And
Have you gone to see it?
he's giving me rides in it. Yeah,
That's cool.
yeah. So
That's what's so cool about the world now is you can like connect with
We're
people
connected,
like
like, I
that.
would've never
and, like,
known.
Yeah,
Exactly.
through a forum, like it's crazy.
yeah, so when I say like at
Like
work
the
in
ducks on the dash of all the Jeeps. Have you guys
yeah.
seen that? The little
The
tiny
duck-
ducks.
Yeah, I'm not
It's
a
just
fan.
it's just a Jeep. It's a Jeep
It's a
thing.
Jeep
It's
thing.
a
I'm
Jeep
not
community
a fan.
thing.
Ugh. I mean, if I drove a Jeep,
Why can't you just get Prince ducks?
I'd be like,
You
and I'd drive off.
you
I
drive
would
a
not
Jeep.
want anybody putting any ducks on my Jeep, man. Please do not touch.
yeah.
I need Sentry mode on my Jeep.
There you go.
See, I like that though. You can have the best of both worlds. You drive a Tesla, and like a lot of people think like it's one or the other, but you obviously
no,
are
it's
very
not,
passionate
though.
about both, and it's not.
Yeah.
It's like
Yeah.
Yeah.
when did you buy your first Tesla?
2018.
When do you think
that
you and
that
I
one?
first started talking about Tesla?
A few years before that. And what did you ask?
I said,
me?
is that one? Is that the
No,
one
that's not the one. The one I bought in 2018, I crashed in March,
Oh, that's the one.
and I replaced it with a new version of a Model S. So I have a 2023 Model S. This is my wife's car, the 2020.
Why did you
Model
go
Y.
with another Model S?
I like them. They're
What do you
comfortable.
What do you
they're
like
good
about
drive.
them?
I take them on road trips. They're comfy on road trips. It drives itself. So,
Yeah.
I can like just.
But it's much bigger than a Model 3, right? Well, why not an X though?
They're very expensive.
X's
And-
are.
Did you've
they're
test
big.
driven an X though, right?
I have. I drove an X, a plaid version of an X, like with ludicrous mode or something a few years back. Yeah, I had my buddy with me. He's had my best friend from high school, or from before high school
You
even.
remember the ride we went on in the D1, the P100D?
No.
We did a test drive. You, Mira, me, and
Yeah.
Jen.
Okay. Oh, the Mira and I were in the back seat. I do remember that. It was quick. And I remember it had a lot of headroom in the back. It was nice. They're bigger than the 3.
Yeah.
They're plenty fast. And I like working on cars. I've had, dozens of cars, and there's very little to do. Like
Yeah.
I've replaced the windshield wipers and the tires.
Right.
I've replaced the tires myself too. Like I have a tire machine in my garage and all that. And so there's almost no work to do on the Tesla. So I have my car time. I'm like fixing lawnmowers, fixing this Ferrari, fixed the Corvette, and this Porsche I got, this 87 Porsche. A good buddy of mine sold it to me, and he didn't do very much with it. And I think the guy who sold it to him was the guy who raced it, and he just like trashed this engine. I measured like how much when the engine when it's running, combustion gas gets past the rings down into the crankcase, right? The rings are worn out, and I measured the leak down, which is like how much you put the piston at top dead center in the cylinder, and you take out the spark plug and you put compressed air into the cylinder, and both valves are closed and the piston's there at the top, and how much air leaks out past the valves or past the rings. is called the leak down rate, and it's anywhere between 0% or 100%. And 100% is very bad, and 0% is very good. And this was the highest I'd ever measured, like 60%. And I'm like, oh, I must be measuring it wrong. Like, this can't be correct. And it was 60% or 55% on all 4 cylinders. So I went and I bought like a professional tool. Like, this was my homemade tool, which I thought was accurate. And I bought a professional tool, and it measured the same numbers. It's like terrible, terrible blow by past the rings. It's worn out. It needs a rebuild, but it doesn't smoke. It's just like so fun to drive. It's perfectly balanced. Like, the engine is in the front and the transmission is in the back. It's perfect 50-50 balance.
How do you think it doesn't smoke?
Dude, I have no idea. Like, that much blow by, you should be like the exhaust. Oh, excuse me. So that exhaust gas goes into the crankcase.
It's not leaking oil into the combustion area. It's going the other way.
Yeah, gas is leaking down into the crankcase.
So you got to change the oil a lot.
Well, it had brand new oil when I bought it, and a case of new oil in the back seat, because that extra pressure in the crankcase blows oil out the seals and gaskets. So I vented instead of the way they manage the crankcase pressure is kind of complicated in the Porsche. I just vented it overboard, so that blow by gas is going into the crankcase and then into the engine bay through a catch can, which holds any oil entrained in that flow of gas. So when I first got it, all that blow by was making a lot of crankcase pressure, and then it was leaking tons of oil through multiple seals in the car, including the rear main seal, which is very difficult to replace. And once I lowered the pressure in the crankcase, all those oil seals leaked much less.
Okay.
And then I looked on the forums, and I fixed most of them very easily. Now the car runs great. I got new tires, and like a week from today, I'm going to go on the first autocross with it. In fact, I got to register for the autocross. I think today is the deadline. So it's just so fun to drive. Like, you could point it and it'll go where you want it to go immediately, and it's just insane.
Rails.
It's like it's on rails. The guy who owned it, the 2 owners ago, the race car driver, he put like the special blue brake fluid in there, which is now illegal. You can't buy that. But like, racers put blue dye in their brake fluid. So when you bleed it, you alternate between blue and clear. So you know when the new fluid is in the whole system. You bleed your brakes frequently when you're racing the car.
And you can't get blue anymore because the dye
It's illegal.
is bad?
It's illegal, yeah.
Why?
The government, Heath.
Yeah, so why is it?
Does the government give a reason why, though?
There is.
They don't need to.
They
have a secret.
They do kind of. There is some logic to it. Like, they do want they want you to sort of be able to tell what's leaking by the color of the fluid. So if it's red, it's transmission fluid. If it's clear, then it's brake fluid. If it's green, then it's coolant. Generally, I don't think that's a strict rule, but
so they can't have clear and blue be brake?
Right. Blue is windshield washer fluid.
No, it's not.
Yeah.
I don't use blue. I use orange. And I mix it with blue.
Use
It ends
orange?
up being green.
Because you're a communist.
It ends up being
Why don't
green.
you
Orange
use red?
windshield wiper
fluids-
Yeah, I use the orange stuff because it removes the bugs and
Yeah.
stuff.
I don't think I've ever seen orange
I
stuff.
think
It's made by what's the company that does the
Rain-X.
Rain-X,
Yeah,
yeah.
it's the
I've seen
Rain-X
that.
stuff. It removes bugs and stuff.
Anyway, so I don't think it's a strict government regulation that it has to be clear. It's just the regulation says you can't add dyes to your color dyes.
So
to
you
the
just
brake
got to
fluid.
buy your brake fluid from another state and have it delivered to you.
You can buy like
Methylene blue.
not people add.
Do you know what
powder dyes
methylene
to-
blue is? You might want to research it for your longevity hack.
Yeah, true.
I'm
it's
serious.
It's in the realm of that biohacking
Okay.
kind
I'm
of.
totally serious. It
Okay.
improves the efficiency of all of your mitochondria.
Nice.
You still taking it every day?
Not every day, but I did take it today.
I took it today.
It's this soluble water dye that dyes things blue, like
It's a stain for microscope slides.
now.
Yes.
Assessments, yeah.
Yes.
Yep.
And what they found out is that it's actually prescribed for certain medical illnesses. I can't remember what it was.
I know they,
But it has a use medically that it's used for all of the time, and I think it's
if you're
also,
poisoned.
I think it's also used for like bladder infections and stuff like that too, because it like comes out your urinary tract and.
Yep. If you get poisoned, like I guess many years ago, methylene blue was in a lot of first aid kits and in hospitals.
Okay.
And if you came in with cyanide poisoning, they would give you methylene blue, and it kind of flushes it out of your
chelator.
system. And
Gotcha.
It collects these heavier elements.
Right.
Is cyanide is that a metal?
It's HCN, so it's chlorine, carbon, nitrogen, and hydrogen.
I meant
It's not a metal.
arsenic.
So if
It
you
was
look
very
at that
specifically arsenic.
can, if you look at that can and read the ingredients, one of them starts with arsenic.
Yeah, I can't read that right now.
You can't see it.
Nah.
It's the arsenic. It's affecting your eyes.
Arsenic and old lace. What? All right. My one more Tesla question for
Sure,
you.
sure.
What? Do you notice a difference because you're driving the 2020, and then you got a 2023. They have different chips in them.
Yeah, hardware 4 on the 2023 and hardware 3 on the 2020.
Yep. So
you guys need to exchange numbers so that he's looking to buy a Tesla.
Yeah. So
sure.
the Intel chip in
Yeah.
the 2020 versus the Ryzen
Yeah.
in the 2023.
Yes.
Do you notice a difference? I mean, obviously you're full self-driving on a 2020, and it's still.
Yeah, I think the FSD does not depend on the hardware in theory.
Yet.
Yeah, it's about to be.
Yet.
But just it's the screen. It runs the screen and the
yeah.
responsiveness.
So the fact that you went directly, he was talking about chips, and you went directly to hardware 4. He understands exactly where you're going with this. That's why I was like, you guys, because
Yeah,
he wants to buy a used one.
Yep, I'm buying
That's what I would
used.
do. I would definitely.
But
buy
I'm
a
trying to
used one.
figure out like what year I want, and I'm like, if I buy, right now I got it narrowed down to a 2022 Model 3. I can get, but it's not.
You don't want a Model Y?
I'm kind of like, it's like, you think that girl's really cute, and then she's got a friend, and she's like, all right. But like over a little bit of time, you kind of decide you like the friend more than the first girl. It's the way I'm starting to feel about the Model 3 versus the Model Y.
Why?
No
pun intended.
I like it. I think it's a cool fucking car.
Okay.
Yeah, I rented a Model 3 in California recently. They're nice.
Was it a new one? The Highland?
It was a newer one. I'm not sure. Yeah, I think it was.
Did it have the light strip?
When you get in,
don't remember.
did it automatically adjust to your profile?
I don't think so.
Isn't there a way that you can just tell it who you are from your other car?
Let's take a break and
Yep.
to it.
Yeah.
Sorry.
Yeah.
Yeah.
We end up usually off on these.
Yeah, we get off on good tangents.
We do.
We do. We certainly do.
We haven't even talked about Mars. Next time,
You're lucky that you already said we're going to close out on Teslas, because now I want you to tell them about the Mars group that you started long before Elon started talking about it.
Oh, I don't think it was before Elon.
Oh, yes, it was. It was before we even started talking about the Hyperloop.
Really?
Yeah, you wanted to have a political conversation about who's going to be running Mars, and you actually got a group of people together to do it.
I did. Yeah, that was.
Well,
pretty
what did you
fun.
call it?
Oh man. I have like the patch. I mean, a little patch. I have to look that up.
You still have all of that?
Yeah, yeah.
Oh,
I'll bring it, yeah.
need to have
It
him
was-
back
it was-
and talk about that.
All right, we'll do. But let's wrap up on Teslas with Zach.
Yeah.
So I love what you're thinking about what you need
Yep.
and what you like,
Yep.
and you could, you probably have some budget.
Yep. Definitely have some budget.
and then
He has an hour drive every day that he's making in that
Okay.
Jeep
Yeah.
out there, and so he wants to take the money he's putting into gas and put it into the vehicle.
Yeah, I'm spending like $350 a month on gas.
Yeah, and
I'm like,
he wants to not He wants to get equity instead of spending and wasting cash.
And I test drove a Model Y, and then I test drove a Model 3.
Okay.
Plus, it would lower his obvious bills on taking care of the vehicle.
Yeah.
Yeah, and I mean, I thought it was great. I fell in love with it.
Yeah, they're so much fun to drive. It'll cost you more in insurance.
Yeah, so that was another
So
question.
you gotta square that away. I'll tell you,
Are you parking in a
garage.
Covered garage.
private garage?
Private garage.
So it's a gated garage.
Oh, yeah.
You make sure that when you talk to the insurance people that you tell them that. Because
Yeah.
you're driving to Baltimore.
Yeah.
That will be important for them to know.
That will be important for them to know.
They
And
usually don't care, right? They just ask you
Yeah.
how many miles.
But
do
if you-
commute.
yeah, in the quotes I've gotten, they haven't asked any specifics like that. But then,
maybe it's a bad thing to mention it.
so a lot of people say, like, oh, but Tesla insurance, they have it in Maryland. You can get it.
Yeah.
But then you're relying on your driving score.
Yeah,
And
I talked to them about it because I'm paying tons of money for insurance.
Yeah.
Because I got 2 Teslas. I had the Corvette until recently.
Yep.
And the Porsche. So I got 4 cars, and
And insurance has gone up recently, right?
it's always going up. And I've been in 3 accidents in the past 5 years.
Oh, yeah.
None of which were my fault.
right.
But
they
they're
take
gonna-
that
they're
into
gonna-
consideration.
So one of the things I did was to call Tesla and ask them specifically about the insurance rates and what makes it go up and down. And it wasn't that good of a deal. Like, if you're super careful and you keep your safety score really high,
Yep.
it's okay. But the minute you forget and go,
You can't
80
drive
miles an
after
hour,
11 p.m.
late at night.
And I don't want to have to think about that if,
Yeah.
I leave
you
Heath's
can-
house late.
Well,
you know?
you can't do that. You work.
Yeah, I have inventory some nights. Next week I have inventory. I'll be out of there at midnight. But, even if I'm here hanging out, and I go home at 11, I just don't want to be driving home going, oh, man, my fucking safety score is going to go down.
stress you out.
I don't want to have to worry about that. So,
What do you think will happen when you can basically just get in the car and talk to the car and tell it to take you someplace? Are you going to quit driving it and just drive on the track?
Yeah, I'll probably do both. I mean,
The reason I'm asking is because of the insurance. Because if I would imagine your insurance would go through the floor once you're just having the car do all your driving for you.
you would think, but
You could be sitting
for
there
example,
surfing your frickin' phone while the car's taking you home.
I already do that. Luckily, I have. It's a really stupid thing to do, but the car drives itself really well.
yeah.
And here's back to your buying decision though. You have to, if you're going to use full self driving on these long commutes,
Yep.
there's 2 ways that they monitor you, either with if the car has a camera in the cabin,
Yep.
it'll be looking at your eyesight, or if it's an older car, you have to pull on the wheel every X seconds that it
Yeah.
I
Nags
thought they
you
got
on
rid of
steering
the what do they call it?
steering wheel nag.
The nag. I thought they turned it off.
I think that's only for the newer cars
Oh.
that have the camera on board.
When I was driving the Model 3 Highland, because I educated myself about FSD and I did it, there were a couple of times when it nagged me. Like, hey, take the wheel.
I don't think it was updated.
The
to
latest,
the newest full
the
self-driving
latest
now.
software, they're going toward getting away from the nag on the steering wheel. But, I mean, the camera is watching you like a hawk. So if you look to change your radio station for more than a few seconds, it'll start blinking lights at you,
Yeah.
and it will kick you off. Like,
How do you get it? When it starts nagging you, what do you do?
you look straight ahead at the car in front of you. Is the fastest way.
So I went and test drove a Model Y, and I was looking at the steering wheel and whatnot, and I was letting it
That's
steer
too
and
low.
everything. Huh?
Looking at the steering wheel is too low. You're not looking at
So
the
I
road.
got dinged
Yeah.
because I was actually watching the panel in front of me that tells me what's going on.
Yeah. A Y doesn't have that. The one with the panel in front of you is the S or the X. The big screen on your right is in all the cars, but the X and the S have a second pod in front. That's where you put your phone if you're watching YouTube. while
So
you're driving.
that's how you bypass it.
Yeah, you can look at that screen actually in an older car. In a newer car, I think that's true also. Yeah, you can.
So I went in and I was like, okay, it wants me to shake the wheel, and as soon as I did that, it popped me out and it said you're a bad
okay.
person.
Yeah, you didn't do it soon enough, maybe.
No,
Well,
I grabbed.
did it have a
I
cam-
literally had my hands like this,
Yeah.
watching the wheel go around in my hands because I was prepared for something like that to happen, and I wanted to counteract it.
Was this
So-
a newer one with a camera inside?
This was one of the newer ones because I was thinking about buying, and it was a brand new one. My buddy Tom from back in Illinois came into town, and he and I both went and test drove one together.
Nice.
And I mentioned to him when we were driving around, I said, "Hell, we used to go to the go kart track together when we were kids, and now we're out in $50,000 cars
Nice.
driving around instead of on
Yeah.
a go kart track."
What do you think about in terms of mileage on them? Like, I hear people say you can 100,000 miles on one of those cars is not like 100,000 miles on a regular car, but then you got things like the control arms to worry about. And
Yeah.
do you think 80,000 miles is like too much mileage if I get a good deal? Like,
I don't think so. I mean, because if there's two things. There's like general mechanical stuff,
yep,
and then there's the battery.
yep,
And so if you want the longest range, you have to get a new battery.
yeah.
But if you're mostly commuting, it doesn't matter. You can have a worn out battery, I think. So, but the general mechanical
How long
stuff.
do the batteries usually last?
There's a car like that's like an airport commuter car that's got like 1 million miles on it. On the original
Well,
battery.
what's the?
They're
Do you
just
know what
not-
the percentage of the battery that still works?
They lose typically on average. They lose like 1% per year.
If it drops,
1 to 2% per year.
and if it drops
range.
below 30%, they will replace it
in a
if-
short enough time.
if you're within the window,
The battery
battery warranty.
Yeah,
Which is 10 years.
I think so. That sounds right. But it's so realistically, like when the S first came out in 2012, right? You could probably get an original 2012 with a super worn out battery. I'm guessing for like $15,000 or $20,000.
Yeah,
And they're just regular. Apart from the battery and the
An
motors,
S
an S. Yeah, S came out in 2012.
with what driving hardware?
Well, that would be too old. And if you want full self
that's
driving,
going to be not, that's
Yeah.
not going to be really relevant anymore.
Yeah.
What's the cheapest with current hardware? Because I think that's what you're really asking.
You can get around that price.
I mean, forget about it being. I think one of the reasons you're heading towards the Model 3 is because they're the cheapest.
Yep, and I've heard
And you
good
wanna
things.
Get into a Tesla.
Yeah, exactly. And the rear-wheel drive has
That makes sense.
LFP battery pack in it that is a little more. It can handle a lot of supercharging. So everything that somebody's done with it up until the point where I buy it,
Doesn't really matter.
the battery's going to be.
could handle it.
It can
Yeah.
handle whatever abuse it might have taken.
What do you
Right.
think about that chemistry versus what chemistries do yours have?
I'm not sure.
It's funny to me
honest.
because I was
Yeah.
researching this chemistry when I first got into drone building,
Mhm.
and I was just like, why isn't this being adopted everywhere? And I still don't really understand it. Is because of the weight of the battery?
I think
Because iron is heavier?
LFPs are heavier,
They are.
Yes.
They are.
and so in a car that matters, and in a drone that matters. But they're being used a lot now for stationary applications.
But you can
for the
pound a nail
magnetic.
through the damn battery and it won't explode. That's how much safer they are.
Most of them are safe anyway. Like the few that do catch on fire, they release all their energy, like, you know, for a long time.
Yeah.
And it sucks. But this kills me. Like, people think the battery fires are more dangerous than the gasoline fires.
Yeah.
No, I was just saying that the LFP ones are that much safer. I know that they should be making the house batteries out of them
Yeah.
because the weight doesn't matter, and literally, like, somebody could run into the battery mounted on the side of your house and it wouldn't blow up.
Yeah.
Do you know why that is? Do you know anything about
Why so?
other than what they can do? Do you know about the danger aspect of the different chemicals?
I don't. I mean, I watched some video on the whole science of the LFP. I forget what the regular one's called, but they don't put that LFP in very many cars. It's really only in the rear wheels. And they're kind of like, it's a much cheaper one to produce. So like the lowest tier Model 3, that's why they put that battery in there.
Yeah.
When they come out with the $25,000 car, Model 2.5 or whatever, it's probably going to have one of those.
So last question.
Sure.
What do you think is going to come out on 1010?
On 1010.
Do you watch the
The
quarterlies?
I do. Actually.
I know I do.
Yeah. So on 1010, I think it's the robotaxi and this low cost car. Probably some of both.
John is
my
also
guess.
heavily invested in Tesla too.
Yeah. I wouldn't say heavily, but pretty
Compared to most
pretty big
people.
well,
is what I meant.
I meant, like, I know guys who are like 100% into Bitcoin. You know, and I think we can maybe talk about Bitcoin next time, but 100% in anything is super risky in my opinion. So I'm like maybe like,
Well, it's definitely volatile.
I'm like 5% in Tesla. You know, this
I just meant that you have more than average.
maybe. Yeah.
I didn't mean to
But
out
there's
you
other
as like this is what
Uber
John's investments
Tesla
are.
bull. Yeah. Yeah. No, like that car I was talking about earlier, that Ferrari is an investment. Like, we wanted to diversify a little.
Yeah.
So that's literally part of my retirement plan, is to put sweat equity into that car and sell it for a lot more.
Do you really
later.
think you'll ever be able to sell it though?
I do.
I don't believe the way you
That
just
laugh
said
at the end.
Dude, I will drive
do.
it. I will drive it a little bit, but I'm going to be afraid to drive it, to be honest with you. Like, on these roads with...
Well, you'll have it
other
insured.
drivers. Well,
And when you're 130, you're probably going to be able to get...
but-
yeah.
when I'm 130, yeah.
Yeah.
The discount on my insurance.
Yeah.
After I drive like a grandpa.
You'd probably be able to install full self-driving by then.
on the old car.
Yeah,
I'll have my Optimus chauffeur drive me around.
that's
there.
what I meant.
Yeah.
That's what I meant. Yeah.
Nice. Yeah, on 10, that'll be interesting. So we got, like, what is that, 6 weeks from now or something?
Yeah.
Is it
Yeah.
whatever
Little-
was
little over
under
6
those
weeks.
covers at that one talk he
It's
gave?
pretty exciting. Yeah.
Are you thinking about getting either one of them?
On the newer cars?
The Robotaxi or the
I don't think so. I mean, you know, I'm pretty happy with the cars we have now. You know, I might get another, like, fun little Porsche or something. I would like to get a car that my wife likes. You know, all these cars have been for me. If you guys hear of any BMW M3 coupes for sale, I don't generally wouldn't buy a BMW for myself, but she really likes that car. I would love to buy one of those and fix it up for her, but they're pretty expensive now. They've caught on and went for the moon, but
she doesn't like her Teslas at all, huh?
oh, she likes the Model Y, but she had a Porsche Macan before. She really liked it because you're sitting up higher. It sounds like a race car, twin turbo. She loved that car. But she likes the Y. And what were we talking about a second ago?
What was that?
My camera just went off.
Oh,
All right, man. Let's
All
wrap
right,
it
man.
up.
Yeah, let's do it.
It was fun.
Let's do it.
Thank you
it was
very
great
much.
show.
It was great. It was great.
My
Good
pleasure.
meeting you.
It's great to meet you, Zach.
All right.
Great podcast and interview.
Yeah, that was cool.